Hey, hi all, faculties, very good evening. Uh, hey, SmartBits team, good evening. So, Surya, you're there?
Yeah, yeah, Kush.
So you will be taking today or Mohan? How does it go?
So I'll be taking initially till something around 6:15. After that, Mr. Mohan will be taking the next part of the session.
Okay, so start will be with you, right?
Yeah,
Okay. So we shall start at the 4:05 because
yeah,
we can't wait, can't keep others those who have joined, uh, can't keep them hold. So we'll give
sure,
five
sure.
minutes time, 4:05 exact. We will start. So tomorrow, we have to start exactly at 4 o'clock only.
Okay,
Uh, so today we'll cut off 5 minutes. We'll start exactly at 4:05.
sure.
Anyways, it is recorded one, so people who missed they can attend recording. Okay. Surya, hi. Maybe you can start sharing your screen. I just gave access to you.
Okay,
Okay, Surya, we shall start. Let me start recording and then hand over to you. Is that fine? You are ready, Surya?
Yeah, I'm ready.
Okay, just a second.
This meeting is being recorded.
Hello, all faculties. Warm welcome for day 5 training on AI, ML, IoT, and Cloud Native for the GuruCool program. So, as part of day 5, our trainer is Mr. Surya, which you all know. He was the one delivered day 1, 2, and 4. So today also he will be delivering. With him, another speaker also will join sometime later. So without any delay, I am handing over to Surya. Hi Surya, over to you.
Yeah, thank you, Tish. So, good evening to all the participants. Hope all of you are doing well. Hope all of you had a good weekend and rest up your minds on the session what we have had. So, today's session would be on machine learning. Okay, so we'll be using a service called Auto AI. I mean to say, kind of an experiment which is there in your machine learning instance of IBM, where we'll be using it for training your models. So here also we'll be going the same approach where we don't code anything. Based on the service available, we'll be using that service to build a model. Okay, so but before going to that, first we have to know the basics of machine learning. So we'll just have a brief intro on an overview of what machine learning is, and after that we'll just move on to our session. So first to know about these machine learning AI, you have to know what is the difference between machine learning, what is the difference between artificial intelligence, what is the difference between deep learning. Most of the people say that so this is based on machine learning. This is built using, or this model is based on machine learning. This is using deep learning. This is an AI model. This is a deep learning model, so like that. So most people say in that way, but you have to understand the difference between that, the approach. What is the difference between AI, ML, and deep learning? With that note, I'll just start the session. So these are the buzzwords which are being associated with artificial intelligence. Yeah. So we all know this artificial intelligence, the word itself, artificial intelligence is just mimicking of human behavior. Okay. The word itself says mimicking of human behavior. Artificial intelligence is just mimicking of human behavior. What are the technique you follow, what are the approach you follow, just human behavior need to be mimicked or it should be replicated. That is nothing but artificial intelligence. Under that artificial intelligence, we are having machine learning. It's a branch of AI where algorithms are used to learn from data to make future decisions or predictions. So here in machine learning, using machine learning, how machine learning does this predictions? It uses statistical algorithms. Machine learning uses statistical algorithms. So machine learning comes under the tree of artificial intelligence. The approach followed by machine learning is through algorithms. Okay. Now, what is deep learning? So deep learning again is a branch of machine learning, okay, which uses artificial neural networks. It is just being inspired by human brain, how our brain works with the number of neurons which are present in our brain. So they work hand in hand to accomplish a particular task or to predict something. Okay, in the same way, deep learning also follow the same kind of approach using artificial neural network. Okay, so machine learning follows statistical methods or algorithms to get these predictions or decisions made, and deep learning uses a different approach called neural networks. Okay, but the end goal is to do the predictions or to do the decision making. Okay, so either of whatever the approach you follow, if it is mimicking human behavior, then that comes under artificial intelligence. Okay, so you can see here we can call machine learning as artificial intelligence, but we cannot call artificial intelligence as machine learning. Hope you got this point cleared. Okay, so it's mainly depends on the approach which is being followed. Okay, so coming to this, how it works, how what is the difference between a traditional programming approach and a machine learning way of approach? Okay, so why to go to that kind of approach? Okay, so first we'll see the traditional approach. So you all know programs. If you take any program, the traditional approach would be something like this. Okay, a small example for you to explain the traditional way of programming. Here we are having data and here we are having a program. We'll be feeding the program or writing the program in the system, and the data is being provided to that program. Based on that, you'll be getting the output. A small example for that is, I just take a small example here. Suppose if you want to know whether the vehicle is going at high speed or low speed or normal speed, okay, over speed, normal speed or slow speed. Okay, in general, what the traditional approach would be? The traditional approach would be like this, where you write some multiple if conditions, nothing but a program, where to that program you'll be feeding data. Data here in this case is nothing but vehicle speed. So you'll be providing the vehicle speed to this program, and the program, based on the conditions which were there, it will just categorize it as whether it is over speed or normal speed or slow speed. This is a traditional programming approach which we generally followed prior to machine learning. Okay, what if the same thing, if we implement in machine learning, how it goes, what would be the architecture of it? That's what we are going to see right now in the machine learning approach. Okay, in the machine learning approach, here we provide data as well as output to your system. Okay, so here one important point you have to remember, in machine learning we won't be building algorithms, we will be building models. Okay, so we'll be applying the data and output to an algorithm so that it will be giving us a model. Okay, so the simple example which we discussed previously, here the data is nothing but vehicle speed. Yes or no on the chats? Data is nothing but vehicle speed. To that vehicle speed we have to provide outputs. So in simple way, suppose 30 kilometers per hour slow speed, 40 kilometers per hour slow speed, 50 kilometers per hour normal speed, 80 kilometers per hour over speed. Okay, like that we need to form a kind of a data set where you'll be having input as well as output. In this case, input output in the sense, you'll be having vehicle speed as input, and output is nothing but over speed, low speed or high speed. Either of the three outputs will be given. Okay, so data would be something like this. So 20 kilometers per hour slow, 30 kilometers per hour slow, 50 kilometers per hour normal speed, 80 kilometers per hour over speed, 90 kilometers per hour over speed. So we need to form this kind of a data set. Now once the data is being formed, we will be giving it to our machine learning algorithms. We'll be giving it to machine learning algorithms. That algorithm will find the pattern between the input and the output, nothing but data and the output. What does the algorithm do? Let's find the pattern which is there between the data and the output. That pattern is nothing but a model. Okay, so in machine learning approach, we'll be providing data as well as output to your algorithm to get a model out of it. That model is nothing but kind of a rule, we can just call it as a rule or a pattern which is present between the given data. Okay, now you might ask, what if a data is not present in my inputs itself? Suppose I have given only with 20 kilometers per hour, 30 kilometers per hour, 40, 50, 60, 70, 80, 90, 100. Okay, so with that inputs only, my model is being, my algorithm, I have given the data to that my algorithm and my model is built. Okay, what if I give 65 kilometers per hour? Will it be giving the output or not? On the charts, what if I give 65 kilometers per hour or 55 kilometers per hour? Will it be giving output? Obviously, because since it has find the pattern, it's not that only the given data will be projected as output. Okay, but whatever the data which is being trained, other than that also our model will be in a position to give the prediction. Okay, that's what prediction, right? Your model will be in a position to give the prediction once the data is being trained with that respective uh, speeds. Okay, so 55 kilometers per hour can be predicted as normal speed. Okay, 60 kilometers per hour, it's already present in the data, so obviously normal speed will be obtained. Okay, so I'm not saying that we need to use machine learning for this kind of an exam, this kind of an application. Just in scenarios where you don't have anything, yeah, you don't suppose I'll just take a small example to give you to make you understand where machine learning can be used. So in general, if you take a recommendation system, in that recommendation system you cannot go and write a program for each and every user. You cannot go and write a program for each and every user. Okay, we need to have a generic model such that that model should be in a position to give the recommendations to the different types of users. Okay, so it has to be, the model need to be built on the data which is already been present with the uh, a company, such that it will be in a position to give the predictions. Okay, so just a basic rule here data and output will be given to your algorithm such that you'll be given with a model. Okay, so in machine learning approach we don't provide the program, we will be giving the data as well as nothing but this data and output is nothing but data set. Okay, to the predefined algorithm. Okay, we have to do some processing on the data and we have to give it to the algorithm such that you'll be getting a model out of it. Model is nothing but a generic pattern or rules which are built based on the data which is being fed to the algorithm. Is it clear on the charts? Please let me know once whether basic thing here, it's a small example, not yeah, again, yeah, we'll be going to the different learning techniques also. A small example of it. Okay, yeah. Now, so as I've said, for we have to apply data to my algorithm to get the model, right? Now there are multiple steps in between the data applying it to the algorithm. There are multiple steps involved before just before applying it to the algorithm. Okay, we'll see those steps. The first step in building a model, is collection of data. Okay, if you take any model, if you take any machine learning model, the first and foremost important thing is data. Okay, so collection of data. So data can be in different forms. Data can be structured, data can be unstructured. Okay, or data can be present in hard disk, data can be present in cloud, in their servers. Okay, so first and foremost thing, if you are going to build a model, first thing is we require data. So step one is collection of data. Next one is data wrangling. Okay, so data wrangling is nothing but cleaning of data. We can also call it as data pre-processing. Data wrangling can also be called as data pre-processing. Okay, so in this step, in this data wrangling, we are having multiple steps involved. So it can be like removing of unwanted information, unwanted records. Okay, unwanted records can also be called as outliers. Okay, and removing of data like if there is any missing data available. Okay, if there is any record which is having some missing data, the data is not available due to some X reasons. Okay, so how to handle it? Okay, how to handle that, whether I have to remove that data or whether I have to do some kind of handling techniques on it to fill the data, to complete my data, to get the complete data. Okay, so all these things, if you are having any characters, okay, characters, you know, right, if you take an example of gender, male, female, like that, if you're having any kind of characters in your data set, okay, how to handle those characters? Okay, because our algorithms are in a position to only accept numericals. Okay, so data wrangling comes under this, where you'll be having multiple steps involved in cleaning of data. As I've said, cleaning of data can be, I'll just give you some 4-5 steps of cleaning of data. One of the things is removing of handling of missing values. The first step in data wrangling can be handling of missing values. Second step would be removing of outliers. Third step would be handling of categorical variables. Fourth step can be something like feature extraction. All these things comes under data wrangling. Okay, so data wrangling is nothing but cleaning of data or processing of data to make our data ready for giving it to the algorithm. Okay, so hope this point is clear. Step 2, data wrangling, and next one is analysis. Okay, so to know the insights of the data set, okay, we'll be doing exploratory data analysis. We call it as EDA, exploratory data analysis, where uh, your data can be visualized such that you can find the hidden insights which are there in it, as well as to find some vitals like outliers. So we'll be using this step to analyze this. We'll be using this as a part of our machine learning life cycle. Okay, so analyzing of data, to know about your data, we'll be using this analysis of data. Okay, so we call this step as exploratory data analysis. So main important reason for doing exploratory data analysis is to know about your data. Okay, next one is training and testing the algorithm. So once your data is ready, so we won't directly give the whole data available with us to build a model. We won't give all the data which is available with us to train your model. Okay, the reason for that is, suppose you're having some 10,000 records of your data. Suppose you're having some 10,000 records. Okay, you're building a model, something like a house price prediction. You're building a model called house price prediction. House price prediction is nothing but knowing the price of the house based on some parameters. Okay, so you're building such kind of a model. Okay, you're having some 10,000 records of previous data. Okay, now those 10,000 records, we don't directly give it to our algorithm to get a model. The reason for that is, once the model is built, we don't know whether the model is giving good accuracy or not. So for that reason, what we're going to do is, we'll be splitting our data into train and test, such that, so training data will be sent to train your model. Okay, so once the model is ready, we'll be testing the model using the test data, which is having known inputs and known outputs. I'm repeating it one more time. So suppose you are building a house price prediction model. Okay, where you need to predict the price of the house based on some XYZ parameters. Okay, so in those XYZ parameters, we are having different prices of the houses. Like you're having some 10,000 records, where you're having each and every record is having some X parameter, Y parameter, Z parameter, and the output price. Okay, so we are having some 10,000 records. In those 10,000 records, we don't directly give the whole 10,000 records to our algorithm to build your model. Okay, so we'll be splitting the data into train and test, such that training data will be only used for training. Testing data can be used for testing the model once it is built. Okay, so how you're going to test it? Because the test data will be having the known output as well. Okay, so we'll be giving the test inputs to our model, such that we'll be getting the predictions. Those predictions, we are going to compare it with our known data. Okay, did you understand this step? Train and test of the algorithm. Training is, so the reason for doing that is, to test your model, we'll be splitting our total data into two parts: training part and test part. Okay, so training part for training your model, test part is to test your model. Is it clear on the chats? Just let me know once. Okay, yeah. So once it is done, once you got your model ready, okay, once your model ready, according to industry standards, suppose if you got more than 70% of accuracy, suppose you got more than 70% of accuracy on your model, the next step would be deployment of your model. What do you mean by deployment? Finally, once your model is built, the final stage will be deploying it in any web application or any kind of mobile application, like that. Okay, So based on the accuracy of your model, we'll be going for the deployment. Yeah, what should be the training size and test size? In general, most of the cases 80-20 is a ratio. That means suppose you're having 10,000 records, 8,000 records will be used for training, 2,000 records will be used for testing. Okay, suppose if you use 50-50, that might reduce the amount of data required for your model to get trained. Okay, it will have insufficient amount of data if you reduce the train data. Okay, that's the reason 80-20 is the standard ratio. Okay, so if you're having a larger data set, something in the form of a lakhs or something like that, you can use 90-10 also. Okay, in most of the cases the ratio would be 80-20. Okay, so these are the different steps involved in your building a model. So just to summarize, the first thing is collection of data. Next thing is data wrangling, nothing but data pre-processing, where you'll be handling the data in the handling missing values or handling categorical variables or handling of outliers. Okay, how to find out outliers and all these things will be found in will be the part of data wrangling. Third step is exploratory data analysis, to know the hidden insights in your data set or to know about your data set. We'll be doing this exploratory data analysis. And next one is train and test algorithms. So as I've said, we don't directly use whole data set for building your model. We'll be splitting it into train and test. Okay, the reason for that is once your model is built, how to test your model, because we need real-time parameters, real-time data. Okay, so at that instance you may not be getting the real-time data and you may not be knowing the prediction is correct or not. That's the reason we'll be leaving out a 20% of data for the testing of your model, such that it is having known outputs. So when you give the known input, when you give the inputs to your model, it will be giving some predictions. Those predictions we are going to compare it with our known outputs. And once it has got more than 70% accuracy, then we call it as, then we can just go for deployment. Yeah, 80 represents 80 records. Okay, 80-20 ratio is nothing but 80% of records. Okay, suppose in 10,000 records of data set, 80 represents 8,000, 80% represents 8,000, 20% represents 2,000. Hope it is clear. Okay, so this is a definition of machine learning given by a scientist called Arthur Samuel. So machine learning is science of getting computers to learn without being explicitly programmed. Okay, here the point explicitly programmed in a sense, we need not separately build an algorithm or write a program. Okay, so based on, so we have to just take care of the data, and once the processing of data is done, then we can just go and apply it to your algorithm to get your model. Okay, so this is the definition, the standard or basic definition of machine learning is the science of getting computers to learn without being explicitly programmed. Okay, so here also there are different algorithms involved. Algorithm doesn't mean only one single algorithm. There are multiple algorithms involved. So we'll just go through that. Okay. So we're having multiple different types of machine learning available depending on the type of data set. We're having different types of machine learning. So the first and foremost thing is supervised learning. This I'll just explain you with a small example. So just to, before going to the example, just to know about supervised learning. So supervised learning, where you'll be having some inputs and output to be predicted. In supervised learning, we'll be having some inputs. Based on the inputs, we have to predict. Based on the inputs, we have to predict the output. Okay. So supervised learning is clearly defined. It is having clearly defined inputs and clearly defined outputs, such that based on that input and output, the patterns will be found between the input and output, and we'll be getting a model out of it. Okay, just to explain with a small example, I'll just take a small example here. As we are talking about house price prediction, I'll just take that example just to make things easier. Suppose if you take the example of house price prediction. So in this house price prediction, what are the main inputs which are required? What are the parameters which are there to predict the house in general cases? What are different parameters we'll be having in general cases to predict the price of the house? On the charts, yeah, square feet, location, very good. So square feet, the first, location, okay, yeah. Is it the type of the house, 3 BHK, 2 BHK, or independent house? Amenities, okay. So yes, and parking for suppose, okay. So we'll just call these, call these as the parameters, okay, just for this scenario. In this scenario, we'll just call these as parameters which are required. So these are called inputs, right? Because we were using these inputs to predict the price of the house. So these are called as inputs. These are inputs for predicting the house. Yeah, we can have a number of parameters. As of now, I'm just taking these parameters. And what is the output? What is the output? Yeah, output is price. Okay, so these are some inputs. The output parameter is price. Okay, so these inputs in machine learning terminology, we call them as independent variables. Independent variables. Inputs are also called as independent variables, and output is called as dependent. Output is called as dependent. The reason for that is, just tell me, is square feet dependent on anything? Is square feet dependent on anything? No, right? So location dependent on anything? No. Type of the house is dependent on anything? No. Amenities? No. Parking? No. Okay. So if you take these inputs, they are not dependent on any parameter. Okay. So that's why these are called independent variables. And if you take this output column, price, is price dependent on square feet? Is price dependent on, yes. Is price dependent on location? Yes. So that if you see here, all these parameters are responsible for the prediction. Okay, are responsible for the price. Okay, that's why it is called dependent variable. Okay, so in supervised learning, you will be having inputs as well as an output to be predicted. Then we call it as supervised learning. In supervised learning, you'll be having some input parameters and an output parameter to be predicted. Then we call it as supervised learning. Okay. So there are other examples for supervised learning. Email spam detection. Okay. In that email spam detection, so you'll be having some n number of parameters whether it is spam or not. Okay. The output parameter will be whether it is spam or not. Okay. So you'll be having some inputs and output here whether it is spam or not. It is a kind of it is a supervised learning approach or supervised learning data. Okay. And if you take one more example, weather prediction. So in weather prediction, you'll be having some parameters like wind direction, wind speed, and all these things. And the output parameter is whether it is going to rain or not. For instance, whether it is going to rain or not. So you'll be having some input and output to be predicted. Then we call it as supervised learning. Is it clear on the charts? The data is labeled if you take in specific, the data is labeled in supervised learning. Okay, so in supervised learning, we are having two more types. One is a regression and other one is classification. In supervised learning, we are having two types. One is a regression. In supervised learning technique, we are having two other types of learning. One is regression and classification. We are having two categories in supervised learning. Two types of supervised learning. One is regression and classification. Okay, so how to identify, okay, how to identify whether it is a regression or a classification, whether a data set is regression or classification. Now you might be wondering why to know about this. Okay, why to know about regression, why to know about classification? The reason for that is based on the type of learning, based on the type of data set, we'll be applying the respective algorithm. For suppose if it is a regression type of data set, then we have to apply regression algorithms to your data set. If it is a classification data set, then we have to apply classification algorithms. If it is a supervised learning, then you have to apply supervised learning techniques. Okay, that's the reason you have to know the type of, based on the type of data set only, we'll be identifying the approach to be followed or the learning type. Okay, so here when it comes to supervised learning, we are having two categories. One is regression and classification. Okay, so what is regression, or how regression can be identified? Okay, so it is totally dependent on your output parameter. To know whether a data set is regression data set or a classification data set, it is totally dependent on the output parameter. Okay, if you take this example, what can be the price of the house for each and every record? Yeah, we'll just come back to that. So what can be the price of the house? Suppose something like some 1200 square feet, just for instance, location in Hyderabad. Okay, type 2 BHK, amenities available, for instance we'll just call it as S, and here S. Just consider the price of the house. What can be the price of the house? Just okay, 60 lakh. Okay, this is one record where you'll be having square feet, location, type, amenities, parking, and this is one record. And one more record you'll having something like 1000 square feet, 3 BHK. Okay, so this is costing something around 65 lakh. Okay, so here the output is not fixed. The output column is not fixed. You'll be getting some continuous value like this, some 65 lakhs, 25,000, 540 or something like that. Okay, if you take this example of house price prediction, the output column will not be fixed value throughout your data set. Okay, the output column will be having some 50 lakhs, 22,000, 60 lakhs, 42,000, or 67 lakhs, 32,000, like that. So your output column is not fixed, it is continuous. So when your output column is continuous, then it is regression data set. We have to apply regression algorithms to that data set. Okay, so if you take this example of classification, so as I've said, email spam detection. What is the output of that email spam detection? What is the output of email spam detection? Yeah, whether the email is spam or not, yes or no. The output will be, if you take the throughout your data set, so whether it is spam or not. Throughout your data set, the output throughout the records, the output will be either yes or no. Okay, the output will be discrete. Okay, the output will be discrete. Then we call the data set as a classification data set. You have to apply classification type of algorithms. Okay, so one more example for it is diabetic prediction, for suppose. Okay, so whether you got a diabetic or not, yes or no. Okay, so if your output is having categories, okay, categories are nothing but your output column is fixed throughout your data set. Okay, fixed in the sense either you'll be having 3 categories or 4 categories, but only those 4 categories will be repeated throughout your data set. Okay, so high, low, medium. Okay, high, low, medium are the 3 categories which are being repeated throughout your data set. Then we call it as classification data set. So if your data set is discrete, or if your output column is discrete, okay, then we have to apply classification algorithms to your data set. Is it clear? Difference between regression and classification on the chats. Okay, so some more examples for classification can be weather prediction, whether it is going to rain or not. Examples of regression can be predicting the population, whether the population will so for this particular year the population is something like 1 or 2 crores or something like that. The next year it will be different. Okay, so based on the type of output column, okay, the type of the data we present in the output column, we will be classifying it as whether it is comes under regression or classification. Okay, so here one key point you have to remember: in supervised learning, inputs are called independent variables. Inputs are called independent variables. Outputs are called dependent variables. Just a second. Yeah, why it is called the name supervise? The reason for that is you are supervising the prediction based on the output column. You are having the output column, right? So this is input. We are just training it, right? So this is input. For that, the output is this. This is the input. For this, the output is this. So we are supervising it based on your output column. Okay, that's why it is called supervised. Hope it is clear. Since we are having an output column, based on the output column only, it is finding the patterns, right? So for this input, the output is this much. So that's the reason it is supervised. Okay. So in the previous example also, the vehicle speed example. So it is, what type of data set is that? The vehicle speed example which I have said. What type of data set is it? It is classification or regression? It is classification or regression? Yeah, it is classification. What is the output over there? High speed, over speed, normal speed, low speed or slow speed. Having only three categories, right, in your output column. That's why it is called classification data set. So for that you have to apply classification type of algorithms. Okay. Yeah, it totally depends on the output column. Okay. So to identify whether it is a regression or classification, it totally depends on the output column. If it is a continuous column, continuous value, then it is a regression. Okay, so this is about supervised learning. So though we'll be discussing about we'll be building a model of supervised learning. Okay, so next, so you can see here, so resolves regression classification problems. Krishnam Raju sir, if speed is changing but output is what? In that example, what is output? In the vehicle speed problem, output is what? Output is low speed, high speed, over speed. So we have to concentrate on output when you're talking about regression or classification. Okay, the speed will be, input will be a continuous value. We won't bother about it. Okay, but the output column, if you see, output column is high speed, low speed, normal speed. Okay, that's the reason it is called a classification data set. Yeah, house price prediction is a regression data set. Okay, the reason for that is the price column is continuous. Okay, yeah. Coming to the next learning technique, which is unsupervised learning. So the word itself says unsupervised. So previously we said supervised because there was an output column. Yes or no? Previously we said it is the data set or the learning technique is supervised because we are having an output column or output to be predicted. Here in unsupervised learning, you don't have any output to be predicted. In unsupervised learning, you don't have any output to be predicted. Based on the inputs, we need to form patterns or clusters, okay, or groups. Based on the similarities of the features, we need to form groups. That is nothing but unsupervised learning. I'm repeating it one more time. In unsupervised learning, you don't have any output to be predicted. Based on the similarities which are there in the inputs, we need to form clusters or groups. Okay, or clusters or groups. Okay, so that is nothing but unsupervised learning. The example for that is Facebook's target marketing, Facebook's ads. Example for that is Facebook ads. Suppose if you take how you will be getting Facebook ads. Example is the question is how you will be getting Facebook ads. In general, you'll be the Facebook will be having different what do you call, different inputs or different features for each and every user. So Facebook might be having his likes, his what do you call, his places he visited, or the videos he watched, the images he liked. All these inputs he'll be having for each and every user. There, the output will not. There is no output in that data set. Okay, So based on the similarities or people who are having similar features, those peoples are being taken, and based and to that particular group a particular ad would be sent. Okay, so here the point which revolves around here is no output is there here. We need to just form patterns, or we need to form clusters to that particular cluster. So we can just form a kind of an example called target marketing. Okay, so the point here is unsupervised learning. The date you will not have any output to be predicted in unsupervised learning based on the similarities which are there in the inputs. Inputs can also be called as features. Based on the similarities which are there in the features of the data, clusters are formed or groups are being formed. So that's what the goal is, to form these kind of clusters. Okay, so one of the algorithms which are there are multiple algorithms which come under unsupervised learning. Okay, so that is the concept of unsupervised learning. Yeah, Facebook. Yeah, the Facebook example is similar to recommendation system also. So recommendation system is also an example, can also be an example for unsupervised learning. Okay, and the last approach is reinforcement learning. So reinforcement learning is a different approach when compared to supervised or unsupervised. Here in reinforcement learning you don't have any data. In reinforcement learning you don't have any data here. Just based on the mistakes or based on the positives, or which are based on the mistakes or positives which are being done by the model, it will just find the correct or right answers or right path. Okay, the best example for that is robot navigation. Okay, suppose you have taken a robot. Okay, so you want to know, you want your robot to go from one corner to other corner. Okay, in that scenario you just place the robot over there. We'll just leave the robot to find the particular correct path. So to identify the correct path, what it does is robot goes in multiple directions. It will just hit different objects. So whenever it hits a different object, okay, we'll be giving a negative reward to it. Whenever it goes in a correct path, we'll just give a positive reward to it. Okay, so this kind of learning is called a reward based learning. So reinforcement learning is called a reward based learning. Okay, so it's a kind of the best example which I've said already, robot navigations, and the chess game. Chess game also is an example for the automatic machine playing the chess game is also an example for reinforcement learning. It just learns from its mistakes. In reinforcement learning, the model learns from its mistakes. Okay, that's why it is called a reinforcement learning. Okay, so these are different learning techniques, but this is bit advanced. Reinforcement learning is bit advanced. Okay, so mainly we'll be concentrating in supervised learning in our practical as of now. So these are different algorithms which come under reinforcement learning is a bit advanced. Okay, yeah, there are some Lakshmi Sri ma'am, actually there are some rules to be followed in reinforcement learning. So you'll be having a state agent. Okay, rules. Based on the rules, it has to follow those rules. Based on the rules, it will just find the different directions. According to the robot navigation example, just go to different directions. So if that state is what do you call a negative reward in a particular state, okay, it learns that okay, this path it need not be followed. Okay, so it just remember or memorizes the mistake, and based on that it just steps on to the next step. Okay, so supervised learning, here we are having multiple algorithms which makes our task easy for building a model. So these are different algorithms. I'm not saying these are only the algorithms. These are basic algorithms, initial algorithms for regression and classification. So linear regression, multilinear, polynomial regression, decision tree, random forest, these come under regression algorithms. And classification, these are algorithms which come under classification. So reason for knowing your data, first if you want to build a model, first you have to know your data. Okay, whether you need to apply supervised or whether you need to apply unsupervised. If it is supervised, whether we have to apply regression or classification. If it is again, if it is regression, whether it have, which algorithm to be followed. Okay, so there are multiple other steps involved. I'm just giving you an overview here. Okay, yeah, a random forest decision tree can be are capable of handling both regression and classification data sets. Okay, the algorithms are built such that it can handle both classification and regression data sets. Okay, yeah, in reinforcement we are having q learning. Okay, in reinforcement learning we are having a technique called q learning. Okay, just you can just google it, different types of reinforcement learning types available. Okay, so if you are a beginner, you have to better to start with supervised learning and go to unsupervised, and after that reinforcement learning. Okay, so with this, hope all of you are clear with the different types and what machine learning is. Just to have a recap what we have discussed. So initially we started off with the difference between artificial intelligence, machine learning and deep learning. Okay, so since we are right now we are concentrating on machine learning, that's why the whole path was on machine learning. Okay, so machine learning uses statistical methods, deep learning uses neural networks. So what are the approach you follow? If it is mimicking the human behavior, then it is artificial intelligence. So the traditional way of programming, machine learning way of programming. Okay, so here you can see the data is labeled for this particular speed, the output is normal, something like that. So the approach followed, the life cycle, the definition of what machine learning is. We have gone across types of machine learning, supervised, unsupervised, reinforcement, and we have seen different algorithms which come under regression and classification. Okay, so shall we move on to our practical part of charts? So we'll just build a model. As I've said, we were doing it from the beginning the way no code no code way of approach. So we'll be using the no code way of approach. So since we are having a service already present in your IBM cloud, so we can just use that service to build a model. Okay, so hope all of you are ready. So yeah, so all of you has open your IBM accounts. All of you just log into your IBM accounts. So in IBM we can write the programming way of, or we can, I mean to say, we can also hard code the your hard code to build a model, or the simple approach or the beginner approach can be using a service directly to build your model. Okay, so we can use two approaches. Okay, yeah, just a minute, let me share my screen. Now we'll be going with the service approach. Just let me know in the chat whether all of you have logged into your accounts. Okay, So we'll be using Watson Studio for building a project, and we'll be associating a machine learning instance to it, and we'll be building the model. Okay. So the first step is to open your Watson Studio instance. So in the first day, we have already created your Watson Studio instance. Okay. So since we have already created it, just go to services. Click on services, the services which are already had. So we are going to start with creating a project. Okay. So this all the flow goes. Just take a note here. Just show it on your notepad. First thing is Watson Studio. Okay, so open Watson Studio, the first step. Second step is create a project. Okay, add auto AI service. Add auto AI experiment to your project. So for running this auto AI experiment, we require a machine learning instance. So create a machine learning instance. Okay, so for running this auto AI experiment, we require a machine learning instance. Okay, so we need to create a machine learning instance, and after that associate machine learning instance to project. Associate machine learning instance to the project. Okay, next one is train the model, or sorry, once it is associated, just take a note of this step so that it becomes handy for you when you are doing the whole process. Okay, load the data set. Load the data set in COS, Cloud Object Storage. Load the data sets to Cloud Object Storage. Select the prediction parameter in the data set. Select the prediction parameter in the data set. Train the model. Once the model is trained, deploy it. Build web application using Node-RED. Okay. Yeah, I'm just pasting it here. Okay. So what you're going to do first, we are going to open Watson Studio, which is already being present. You're going to create a project in it, add auto experiment to it, create a machine learning instance, because to run your auto experiment, we'll be requiring machine learning instance. Since that's the reason we are going to create machine learning instance, associate machine learning to project. Okay, and load the data set which you want to train, and select the prediction parameter in that data set. Train the model. So once the model is trained, we'll be deploying the model, and we'll be testing it over there, because we're going to deploy it based on the accuracy which you're going to get. Okay, and building the web application using Node-RED. So when you deploy it, you'll be getting a API here. Okay, when you deploy it, we get an API. We'll be using that API in our web application to get the predictions. Okay, So hope all of you have taken these steps on the chats. Yes. So we'll be using these steps one by one, and we'll be going to our approach. Okay. Yeah. The first step, open Watson Studio. So all of you just click on services. Did you find Watson Studio in your services? On the chats, did you find Watson Studio? Okay, yeah, click on that Watson Studio. So final output would be, we'll be building a web application where when you give some input parameters, that input parameters will be sent to our model and we'll be getting the predictions in our web application. That's the whole thing here. So click on get started. Click on get started. Vijay sir, Vijaya ma'am, if you didn't get Watson Studio, the reason for that is you may not have created on the first day. If you haven't created, just go to catalog and search for Watson Studio and create the service. Okay, mentors, please just take care of the chat. All of you in this page. Yeah, cool. So in this page, if you just click on projects to the left side, you can see here projects. Just click on the projects. The left side you can find projects. Click on the projects. This will show you the list of projects available. So don't worry, I'm having some extra projects, no problem with that. So hope all of you have opened this page of projects. I'll be going a bit slow, so just so what is the first step? We have opened Watson Studio service. Okay, the next step is create a project. That's what we are trying to do right now. So hope all of you are in this page. Shall we move on to the next step? Yes, yeah. So to the right side corner, you can find a new project. New project. Yeah, click on new project. You'll be getting this kind of a UI where you'll be asked to, you'll be getting multiple options like create an empty project or create a project with sample file. Okay, so we're going to start with from the scratch itself. So that's the reason we'll be starting with creating an empty project. So you can see here, new auto experiment tool, fully automated approach to build a classification or regression model. Okay, that's what we are going to explore in this page. All of you, just click on create an empty project. So as I've already mentioned, when you want to create a project, the first and foremost thing you require is cloud object storage. Okay, so this cloud object storage will be automatically present if you have done on the first day. If you're not having, you'll be asked to click on add. Okay, and when you click on that add, you'll be open with a new window where you can just create a cloud object storage service over there. Okay, so hope all of you are having cloud object storage. On the chats. Yeah, people who are not having, okay, you'll be getting an add button here. When you click on that add, you'll be opened with a new window where you can just scroll down to the bottom and just click on create over there. The cloud object storage will be created. Just come here and just click on a refresh. You'll be getting the cloud object storage service. Okay, just ping to the mentors if you're having any problems with this. Okay, yeah. So give the project name here. I'll just give it as machine learning model. Machine learning model. You can just give any name over there. I'm just giving name called machine learning model. Okay, now just click on create. Now just click on create. Vishal sir, you have to click on a new project. In that, just give the name of the project. You have to select create an empty project and you have to give the project name. Okay. Also in this page, so some of you are having some problem. Yeah, just refresh the page once. Try it out. Refresh the page once. Got it? Yeah. Small glitch might be. Yeah, people who are getting, you can have only one instance or something like that. The reason might be you have already created the this cloud object storage. That's the reason you cannot create multiple instances of the same kind. That's the reason you might be getting that error. Okay, so now what's the next step after this? What's the next step? Add auto AI experiment to your project. Add auto AI experiment to the project. So we'll see here. So you can see to the right side corner, you can find add to project option. Did you find it? Okay. Yeah. Click on that add to project. You can find auto AI experiment. Auto AI experiment. Okay. Hope all of you are able to see that auto AI experiment. Click on that auto AI experiment. So as I've said, we need not do any kind of hard code programming here. We'll be getting it directly we'll be building a model directly using this auto AI experiment. You can see here we are already having a small example here, gallery sample. So, but we are going to create a new one. So just click on this new. Okay. So this is sample one, which is being having with an existing data set and already been built. Okay. But rather than it would be easily understood if you create a new one. Okay. So just click on new here. All of you in this page. Yes. Yeah, that's cool. So give the name of the experiment. Okay, you have to give an experiment name. So I'll just give, say, machine learning model. Okay, you can just give any name over there. As of now I'm just giving it as machine learning model. Okay, you can just give any name over there. Now, as I've already mentioned in the steps, so create a machine learning instance. Okay, so why are we creating a machine learning instance? The reason for that is we're going to use an auto for building this, for using this auto experiment. We require this machine learning instance. Okay, yeah, we'll be using a separate data set. We'll be discussing about the data set. Tomer sir, I'll be giving a data set, so we'll be using the data set. No problem with that. Okay, so as of now we didn't go through the data go we didn't go to the data set as of now. Okay, so once we are set up, we'll be, when you come to the importing uploading of data set, then we are going to discuss about the data set. Okay, all of you in this page, did you give the name of your project auto experiment? Yeah. So you can see here, Watson service instance, no machine learning service instance associated with your project. Okay, so associate a machine learning service instance with your project. So we need to associate a project. So as of now, just click on associate a machine learning instance. Just click on this. Click on associate a machine learning service instance. When you click on this, automatically will be open with a new tab where we can create the service. What you have to do, just click on this associate machine learning service instance. I've been directed to this page. All of you on the chats. Now what you have to do is just click on new service. Just click on new service. Click on new service. So you'll find all the AI and machine learning services present in your, all the categories of AI and machine learning. Okay, so scroll down to the bottom, you can find machine learning. Did you find it? Yeah, just select that. It covers under right plan itself. Just click on that. Okay, so you can see here the region you got, and these are the limitations which come with the light plan. Yeah, so you can just select the default region which is there, so just let it be Dallas itself. Okay, so you can see here 20 capacity units per hour and maximum of 1 GPU. So these are some limitations, and auto experiment can run on these configuration systems. Okay, so there is a limitation here. Okay, so our model will be enough. What are the models which are going to build today? Doesn't require much of the capacity units per hour. Okay, so we'll just select the light plan, and if you scroll down, you can find the name of the service. So the name of the service can be anything. The name of the service can be anything. So you can just leave it as it is, the service name, and just click on create. Click on create. Nothing here. What you have to do, you have to click on this associate machine learning service instance. Once you click on this associated service instance, you'll be directed to this page. So where you have to just click on create. Yeah, it is having limited support for GPU in the free plan, Rakesh sir. Okay, so did you get your machine learning instance here on the chats? Yeah, if it is asking to delete the previous, if you have created machine learning instance previously, then you have to delete it. Okay. Previously we didn't create machine learning instance. I don't know how you got it. Okay. So how to delete it? You have to go to your dashboard. I'm just showing it. 1 second. People who are facing the problem, you can also use the existing service of machine learning, but it might confuse you as of now. Okay. So if you want to delete it, you have to go to dashboard and yes, click on services, and there you'll be getting 3 dots for each and every service. Okay, you have to click on that, you have to click on delete. Okay, so this is for the people who are facing the problem. So we are here right now, all of you in this page. Yeah, people are not able to follow, at least just note down the points. Okay, so just click on the machine learning instance which you have created right now. Click on the machine learning service instance. You will get an option called associate service. Select that option, select associate service. Did you find it? Associate service. Click on that associate service. Click on. I'm just showing it one more time. See here, first you have to find your machine learning instance here. You'll be getting your machine learning instance created. Once it is created, you can find it here. Once you got it, just select this machine learning service instance. Did you find it or not? Did you find this associate service instance? Okay. Just click on that associate service. Click on associate service. Just a second. So all of you are in this page. So you can just click on this reload option here. Just click on this reload option. Automatically your machine learning service will be associated. Did you get it here? Your machine learning instance. Okay. So what are the model you are going to build? Okay, that will be running on this configuration CPU, 8 core 32 GB RAM CPU. Okay, whatever your what are the experiment or what are the model which is going to be built, that will be run on this configuration CPU. Okay, by default this update. So all of you in this page, just ping me once for just for once. Yeah, I see a lot of S. Yeah, now just click on create. Now just click on create. Is it done? Just a minute for me. Yeah. We have done till here. We have done till step number 5. We have done till step number 5. So it will be asking you to add data source. Okay. Now what you do is just go to our GitHub link. Mentors, just post that GitHub link on the chat once. Mentors, just post the GitHub link on the chat. Yeah. So you can see here. Yeah, actually we have added some extra files today. So better I'll just show you this one. You have to go to that GitHub. We have just posted on the chat. Just check it once, the link. Okay. In day 5, we have to obviously have to clone it one more time. Okay. Download zip one more time because we have added some extra files here. In day 5, if you just check it out, we added some CSV files and this JSON format, the flow here. So better all of you just download the zip file, download it and extract it and go to day 5. Download it and go to day 5. Extract the zip file and go to day 5. You'll find your that is day 5 actually. Day 5. Go to day 5. You'll find a data set called 50 startups. I'll just open it also just for your information. This is the data set what we are having. Okay. CSV represents comma separated values. CSV represents comma separated values. Okay. Just give you 2 minutes of time to make sure all of you are ready with the zip file. I mean to say the data set. Just let me know on the chat whether you have downloaded it or not. Yes. Yeah. I'm repeating it one more time. People, actually, we have done the modifications in the day 5 folder. So just people who have already think that they have downloaded. So make sure you download the current one. Okay. Yeah. So if you go to day 5, in that you can find 50 startups.csv. 50 startups.csv. Okay. So here the data set is quite straightforward. Okay. So here this is the data set of a company. Okay. So which is having branches in 3 different regions: New York, California, and Florida. Okay. And these are the respective profits. So what the intention of this data set is, we have to predict the profit of the company. We have to predict the profit of the company based on these parameters, based on these features: R&D spend, administration spend, marketing spend, and state. Okay. Okay, what you have to do? So we have to predict the profit of the company based on R&D, the amount of money they have spent on R&D, amount of money they have spent on administration, amount of money they have spent on marketing. Okay. And in this particular branch of that company, okay, we have to predict the profit. Now just let me know whether it is a classification data set or a regression data set. It is a regression data set. The reason for that is, if you see your output column, the output column is continuous. We're not having a fixed value. The output keeps on changing. It is a continuous value. Okay, that's the reason it is a continuous. It is called it's a regression data set. Okay, so we have to apply regression type of algorithms. Okay. Okay, all of you are able to see this data set in your laptop also, right, in your PC, because the same data set we have given it in your which you have downloaded. Okay, yeah, we'll show that which algorithm which we are going to use. Now come back to your IBM cloud. Come back to your IBM cloud. Now just click on browse. Click on browse. Please don't go ahead. Okay, there are some things you have to consider. Okay, just click on browse. Okay, so load that 50 startup data set. You'll find it in your day 5 folder. I'm having it in different location. No problem with that. Same data set, 50 startups. Okay, just browse it and just click on open. Shashikant sir, you have to go to this file, and yeah, you'll be getting the option to download. You have to go to GuruCool and you can download the zip file. Okay. Is it done? Also got this page. Now you can see here this is the data set which was loaded, and there are 50 records in the data set. So what do you want to predict? What do you want to predict? It's a small data set, that's the reason it is not able to find it in KBs. You have to predict profit. So you can see here, you have to select the prediction column. So select the profit. Select profit. So you can see the type of data for respective columns, having decimal, string, decimal, and all. Okay. So just click on profit. When you click on profit, you can see here Auto AI experiment has automatically identified that as a regression type, prediction type as a regression. Did you get it? On the chats. Did you get it? Automatically based on the type of column, based on type of data available, based on type of output, it has automatically selected the category as a regression. Optimization metric. Optimization metric, you're having RMSE, root mean square error. This is nothing but how you're going to evaluate your model on what parameters. Okay, so RMSE represents a root mean square error. There are different other metrics like mean absolute error, mean square error. For regression, you're having different optimization metrics. For category, for classification, you're having different optimization metrics. If you want to change the optimization metrics, you can just go to this experiment settings. Okay. Yeah, I'll show you that. Just click on this experiment settings. So you can see here data holdout and all these things. So training data 90%. 3 folds. Folds are nothing but cross validation. Okay, there's a concept called cross validation where your data set will be divided into three three subcategories. Okay, and the model will be trained and the data will be trained on those three folders, three subcategories. Okay, a bit of concept involved over there. Okay, so just for instance, 3 folds are nothing but cross validation. Okay, that's what you can see over there. Cross validation divides the training data into folds or groups to test your model performance. Yeah, so here 90% for training and 10% for testing. And if you see here the columns which are there, and if you see a prediction, just click on prediction to the left side. So you can see here multi-class classification, binary classification, and regression. So our prediction type is being automatically selected. So if you want to forcefully change to other categories also, we can do it. Okay. And these are different metrics which are available for regression. Okay. And you can see this is the recommended metric for regression. We can also change it to this like this. Okay. So let's stick on to the recommended one. Okay, I'll show you one more time the uploading part of the data set. Okay, just a minute. People who are there, just hang up over there. Don't come back. Okay, so people are talking who are not able to load the data set. Guys, people, it is very simple. I've already mentioned you to download this zip file. Once you download it, extract the zip file in your system. Once you extract the zip file, you will find a day 5 folder. In the day folder, you will find this 50startup.csv. We'll be using this dataset as of now. So to do that, what you have to do to upload that, go to your cloud object storage. Go to your IBM cloud. Click on browse. Okay. Direct to your location where you're having the dataset. I'm having the dataset somewhere here. Okay. You'll find your dataset in your day 5 folder. Okay. Select that for dataset, click on open. I'm already having it, so that's the reason you'll be automatically getting it. Okay, I'm already having it, that's the reason I've selected it, which I'm already having. Once you have selected that, you'll be asked to select the prediction column. Here I'm going to predict profit. Okay, so I'm going to select profit because that is our prediction column based on the R&D, administration, marketing, and state. You're going to predict the profit of the company. That's the reason we have selected the prediction column. Okay, for auto experiment, we have to specify which column you're going to predict. Okay, and based on the column which you have selected for prediction, automatically based on the type of the data, which is based on type of the data which is available in that profit column, it will automatically identify whether it is a regression or classification. That's what which is being mentioned here. And the default metric is RMSE, root mean square error. So if you want to change those, you have to click on experiment settings. When you click on experiment settings, you can find the amount of data for training which is being sent, 10% for testing. Okay, since we are having a smaller data set, so it's better to go for 90-10. If you scroll down, these are all different columns which are there, and profit is your prediction column. Okay, so we can also remove a column if you don't want a column to be added to your prediction. If you don't want a column to be added for predicting your profit, you can also remove that. As of now, I'm just selecting all the columns. Okay, so if you just click on prediction here to the left side, you can find multi-class classification, regression, and binary classification. So we can also change it, but it is obviously the output column is regression continuous value. That's the reason it is automatically selected as regression. And here also root mean square error, the default metric to evaluate your model. Okay, so if you want, you can just change it to different evaluation metrics. And if you scroll down, these are all the different algorithms which are there in your auto experiment which support the regression. So we are going to use all the algorithms. Okay, among these algorithms, which one got good efficiency, good accuracy, okay, or a good less root mean square error, that we are going to consider. Is it clear till here on the chat? Please let me know once. Yeah, this step is nothing but our auto experiment will use all the algorithms one by one, and among those algorithms, which one got good accuracy, which algorithm got good accuracy, okay, which algorithm which was built on the data got good accuracy, that would be considered. Okay, so that's the reason. If you want to modify this also, you don't want a particular algorithm to be run, you can also remove that. Okay, so as of now, we'll be selecting all the algorithms. Okay, just click on save settings. Yeah, it will show the comparison also. Now just, yeah, just click on run experiment. All of you in this page, just click on run experiment. Okay, yeah, comparison will be done. Which one? So some of you are asking how to know which algorithm is good. Okay, so as of now, in this scenario which we are talking about, based on your the less root mean square error, which one got less root mean square error, that would be having that algorithm. We can just consider it as a good algorithm on the data set. Okay, on the data set, which one got good less root mean square error, that would be considered as a good algorithm. So this will take some time, 2 to 3 minutes. Okay, all if you're in this page, did you get this one? Yeah. Yeah, what is happening here is, so one thing is, as a if you remember the life cycle of our machine model building, all the process will be happen in the back end. It is that for the whether there are any null values, if there are any null values, how to handle it, if there are any categorical variables, how to handle those categorical variables. Okay, all this process will be happen in the back end, and once it is done, the data will be applied on the algorithm of decision tree or random forest or XGBoost algorithm. All this it will, excuse me, it will be applied on all the algorithms. Okay, and will be built, and out of it model will be built. It will take some time. If you have done any changes, then only save settings button will be obtained. Yeah, actually, it depends on the size of the data set. It's not like 10,000 rows or something like that. So it totally depends on the light plan capabilities. Okay, in paid plans, you can just go as much as you want. So these pipelines are nothing but on each and every algorithm. The model will be, I mean, for each and every algorithm, the data will be sent. Okay, and your model will be built. So we are in which step right now? We are in which step on the charts? We are in 8th step, training the model. Yeah, at the bottom you'll be getting these. You can see here pipeline 7, pipeline 6, pipeline 4, 3. So at the top, which one got highest rank? That would be your final model. Pipelines are nothing but, so different ways of pre-processing, different ways of what do you call, hyper-tuning the parameters which are there for the algorithm. Okay, so much of concept involved over there. Okay, in general, as of now, you can just consider it as multiple algorithms. Each pipeline can also be called an algorithm. Different approaches for applying it on the algorithm. Still it is going, it's not yet completed. You can see here running. You have to get model completed or something like that. So it will just take 2 to 3 minutes. So you can see here experiment completed. You have to get it like this. You have to get it like this, experiment completed. How many of you got it? Just let me know in the chats. You will wait for 2 minutes. Yeah, 1 second, 1 second. Okay, you can see here the star mark. This is the top performer for that particular data set. Okay, which got something around 9740 as accuracy. Okay. Shall we move on? So you can see this is the algorithm, ridge algorithm, which is being used. Okay, here extra trees, nothing but random forest. Okay, extra trees regressor is one more type of one more algorithm, one of the algorithms in regression. Okay. No, pipeline is not number of CPUs used for processing. There are some other approaches. Actually, if you go in detail about machine learning, there while building a model, you'll be asked to perform different normalization on it, different techniques, different normalization techniques, feature extractions on it. Okay, and as well as hyperparameter tuning on the algorithms. So each one will be a separate pipeline. So in the backend, we cannot directly go and debug those. Okay, so we are having the feasibility of selecting the type of algorithms and selecting the type of the type of prediction parameter. Okay, yeah, it has. We have used it has used only 2 algorithms. The reason for that is it has uh, the algorithms which are there other than these are having more what do you call error rate. Okay, they are not suitable for this data set. Okay, it has automatically identified that for this data set it is not suited. That's the reason. Yeah, break will be around 6:15. At 6:15 we'll be having a break, so please, so hope all of you have done till here. Now just click on save as and just click on save model. Click on save as and just click on, did you get this option, save as model? Did you get this option? Yes. Yeah, save the model. So let it be the same name, no need to do any changes to it. Just click on save. Click on save. RMSE represents a root mean square error, so it has to be less error. Okay, so did you get this view in projects? Click on this view in projects. Yeah, we have to save the top one. Just click on view in projects. Yeah, once the model is completed, the training is done, you have to click on this topmost one and just click on save as model. Okay, Just see here once on the screen, Kriti ma'am. Okay. All of you got this view in project? Yeah, click on that view in project. Now we got that model ready. We have to, what's the next step we are having? What's the next step we are having? Deploying it. So you can see here, all of you in this page, let me know on the chats. Okay. Now yes, click on this promote to deploy space. Promote to deployment space. Click on promote to deployment space. Click on promote to deployment space. Click on promote to deployment space. Please be a bit fast. We are just deploying a model. Okay. Watson machine learning, WML, Watson machine learning model. So all of you got this? Now just click on new space. So we have to create a new space to deploy it. Click on new space. All of you in this page? Yes. Yeah. Click on new space. So here we have to give the space name. So you can just give any name, the same you want. So machine learning model. You can give any name. I'm just giving it as machine learning model. Excuse me. Machine learning model. Given all of you. So you can see here the model will be saved in your cloud object storage. Done? Yeah. Good. Now just click on create. Now we are going to create that deployment space. Click on create. Yeah, sorry for that. Yeah, you have to select that, but it's optional obviously. No problem with that. You can see it's optional. That's the reason you are not asked to do. You can select your ML service. No problem with that. Okay. Just click on create here. Click on create. So why we are creating this deployment space? Because whatever the model which is being built, that model should be in a position to interact with the web application. Okay. So if a web application wants to, or obviously if you want to interact with this model, interaction is nothing but get the prediction from this model. You have to deploy it. When you deploy it, you'll be getting an API which can be used for getting the predictions. All of you got this? Yeah, see a lot of this. Let's click on close. Click on close. Okay. So the space is already created here. Target space is created now. All of you got your space here? On the chats. Now just click on promote. At the bottom you can find promote. So this will promote such that you will be getting the API for your deployment. Click on promote. Click on promote. Hope all of you are able to see this. Promote. Click on promote. Okay, so all of you got this deployment space option. Go to deployment spaces. Okay, so even though if you didn't find it also, once you got it executed to the left side, all of you in this page, once let me know on the chat, all of you are in this page. Yeah, now just click on this navigation icon. Click on this navigation icon. You'll find deployment spaces. You define it, deployment spaces. Just click on view all spaces. Just click on this navigation icon and just click on under deployment spaces. You'll find view all spaces. Click on view all spaces. Have you got this one? Yeah, start tour and all. Just you can just maybe later or something like that. So select your machine learning model. Select this one. Select this option. Select that. Got it? Now just click on your model. Click on your model. All of you in this page, click on your model. Click on your model. Okay. Also got this page. Okay. Now just click on create deployment. So here we're going to deploy it, the whole final deployment where you can just get an API. If you're getting error battery gateway or something like that, reload the page. Okay. Now click on create deployment. Click on create deployment. So here either you have to use it as online or batch. Online is nothing but where you can just get it as a web service request. Okay, so you can see here run the model on data in real time as a data is received by web service. This is nothing but an API. Okay, all of you in this page. Yeah, just click on this online option. Give the name of the deployment. I'll just give it as project 1. So you can just use any name. Select the option of online such that you can see run the model on data in real time. Okay, so where you can receive by using web service. Okay, so just give the name as project 1. Got this, all of you? Yes. Yeah, now just click on create. Just click on create. You can see here assert is deployed. In the previous step, I think you should have selected that optional as machine learning. Okay. You might have clicked it multiple times if you got it like that. How many of you got this page here? Mentors, please take care of people who didn't get it. Okay, because we are running out of time as of now. Just let mentors please help them once. Okay. Now, once you got this, just click on your project. Okay, click on this. Once you got this, just click on this one. Click on your deployment. So you can see here, these are the API references which you have. Okay, so if you want to use curl, Java, JavaScript, Python, Scala, Python, okay, and this is your endpoint where you can just use it directly. And here also, all of in this page, all of you got this one. Yeah, try to refresh once people are facing a problem with that no space available or something like that. So click on test here. You can also give the values here. Okay, so you can just give here, give some values here. You can also give the values of the record. Okay, and here give it as New York as the city name. Click on predict. You can see the value here. This is the profit which has predicted. Okay, you can give the record values and check with the actual values. I'm just saying this one. You can just give any of the record values, these values, and just check whether you're getting correct profit or not. Okay, so all of you, we require is API references. We require is API references. People who are not getting, at least just take a note of the points as of now. You'll be getting the recordings, right? So, and we'll be helping you out in the channel also. So no problem with that. Okay, at least as of now, just take the note of the steps. Okay, because once it is, we have already deployed it, right? I cannot go back again and change it. Okay, it might totally confuse all others also. So for that reason, what you do is, as of now, just note down the steps what we have done. Okay, till where we got, and after that, what what you didn't get, you can just take a note of it. Okay, so that would do as of now. So got this one, got this endpoint and all on the chats. Yes, yeah. See people saying yes. So now what you're going to do is, you're going to create a web application using Node-RED. So what you do is, all of you just come back, just leave this page as it is. No need to do any changes. Okay, just leave this tab untouched so that we can use this API endpoint. Okay, so just go to this resources list. You define this one, your dashboard. All of you just go to dashboard. In the previous tab, you might be having one of the tabs you'll be having IBM Cloud. Just click on the dashboard and go to your dashboard, because we will be opening our Node-RED as of now. So all of you in your dashboard, break is around 6:15. Okay. Yeah. Just click on Cloud Foundry apps. Go to Cloud Foundry apps. Just open your Node-RED, which you have already done. No need to add any values here as of now. Okay. Just leave it as it is here. Okay. In the API references tab, you'll be using it in your web application. Okay. Go to your Node-RED by going to dashboard. People who are not able to follow in this step till here, at least just take a note of the points. We'll be getting a recording, so you may get the result. You might use the recordings. Okay. So all of you in your Node-RED page, in this page, yeah, click on visit app URL. Click on visit app URL. Go to your Node-RED flow editor. This was previously done, so that's the reason I'm going a bit fast here. Okay, because Node-RED, you know how to open, right? You have to go to your dashboard. In the Cloud Foundry apps, just click on the name of it. We'll be getting this page. Visit app URL here. We'll go into your Node-RED page. So in that, we'll be importing the flow here. So in your day 5 folder, you'll find ml.auto.ai.json. I'm just showing it. All of you just click on new flow. Click on this new flow. Disable the previous flows. How to disable it? Double click on it. Double click on it and disable. Okay. Open new flow. In this page, all of you, yeah, disable the previous flow. That's it. Okay. What are the flow you're having previously? Double click on it and you'll find an enable option here. Just click on that. The flow will be disabled. Just click on done. Okay. And yes, click on this plus icon for the new flow. This flow will be opened. All of you in this page, just let me know on the chats once. Yeah, see a lot of us. So what you do is, now we have to import our file. Okay. So what you have to do is just click on this navigation icon which is there, or top right corner navigation icon. Click on import. Did you find it? Click on import. So select a file to import. You can find your file in your day 5 folder. Select your file. In the day 5 folder, you can find it. In the day 5. Okay, I'm having it in day 4, no problem. But your file name will be ML Auto AI. You define it ML Auto AI file. In your day 5 folder, you will find ML Auto AI file. Yeah, it is JSON. ML Auto AI file.json. AI.json. Did you find it, all of you, on the chats? Yeah, click on that. Click on open. Click on import. You get a list of files, a list of nodes added. how to import it, I'm just showing one more time. Just click on this navigation icon. You have to click on this import. When you click on import, you'll get this option. Select a file to import and import it from your day 5 folder. Okay, all of you in this page now. Okay, first I'll tell you the modifications which you have to do, then after that I'll explain the flow. Okay, the first and foremost thing which you have to do is all of you having this tabs which are there for your IBM cloud. Just open one of the tabs, any of the tabs which consists of your dashboard icon. Yeah, I'll tell you, one second. This tab, either of it. Okay, the IBM cloud icon which I have it. You define this manage option on the chats. You define manage option. See here, just go to your IBM cloud icon. You'll find this manage option here, the right side corner. Yes, yeah, I see people saying yes. Click on this manage. Click on this manage. You'll find access IAM. You defined it? Access IAM. Yeah, the reason for that is we are going to create API key. Okay, to access your deployment space or access your model, we require this API key. Okay, that's the reason we are taking this API key from IAM to IAM, from this IAM. Okay, just click on this IAM. You will find API keys. Did you find this option, API keys? Yeah, click on that API keys. You get list of API keys, but no problem, we can create our own API key. Okay, all of you in this page. Yeah, see people saying yes. Now click on this IBM cloud, create an IBM cloud API key. Click on this, create an IBM cloud API key. Just give any name over there. I'm just giving it as project. You can give any name. You can give any name. Just click on create. Click on create. Is it created for all of you? Now just click on this copy icon. Click on this copy icon. Click on this copy icon. Your API key will be copied. Done. Click on the API key icon. Your API key will be copied. Yeah. Now come back to your Node-RED. Come back to your Node-RED. Open this pre-token. You can find this pre-token function node, right? Open this pre-token function node. You'll find a space to pay for your API key. Did you find it? Did you find a space to your API key here? We are having var API key. Okay, yeah, remove the API key which is there and paste your API key. Paste your API key. Paste your API key. Okay, this will be unique for each and every user. Okay, now just click on done. Okay, Now come to the second HTTP request node. Did you find this one? Second HTTP request. Just see on the screen properly. The second HTTP request. This is your endpoint. Okay, where you have to place it. Double click on this HTTP request. You're having a URL here, right? On the chats. Yeah. Just select it. Drag it till this predictions. See on the screen once properly. Please pay attention here because this is a small minute thing which most of you people miss out. People might delete all the whole URL, but make sure that you remote till predictions. Just click on the backspace. You should have only question mark version equal to like this. Did you find it? Is it done till here? The second HTTP request node. The second HTTP request node, Ramesh sir, Dr. Ramesh sir, in the second HTTP request node, not the first one. The second HTTP request node. Okay. Now come back to your machine learning deployment tab. Come back to your machine learning deployment tab. In this tab, all of you in this tab. Yeah, copy your endpoint. Copy your endpoint. No need to select anything. Just click on this copy endpoint. Copy option here. Done. Copy your endpoint. Just click on that. It will be copied. Now come back to your Node-RED. Come back to your Node-RED and paste your endpoint here. Before the question mark. Paste your endpoint before the question mark. Done. Okay, now just click on done. What you have to do, you have to place your endpoint here. You have to place your endpoint here. Mumtaz ma'am. You have to place your endpoint here. What are the endpoint which you got here? Copy the endpoint, go to your Node-RED and paste your endpoint here before the question mark. Okay, now just click on done. Deploy it. Click on this deploy option. Is it deployed for all of you? Now go to your UI. How to go to your UI? You can just click on this graph icon which is there here and click on this link. Click on this link. Also, did you get this one? On the chats. Okay, now give your values here. Any values? You can just give the values from your dataset also if you are not familiar with what to give. Just giving some values. Give it as New York. Just click on submit. You can see the prediction which I got. This is the amount of what do you call the profit which you can expect with these parameters. Got it, all of you? Okay. Yeah, just to confirm what has happened here. So first of all, to get this API request, okay, use this API to use this endpoint, we have to generate a token. You can see here, people, I'm just explaining it. Okay, the values are, yeah, you can also include the UI values in the UI also, the units in the UI also. I'll just make it quick here, 2 minutes. Okay, to use this endpoint, we need to have a token. Okay, you need to have a token. So for generating this token, you require an API. Okay, you can just click on this. When you click on learn more, you'll be getting the information about it. Okay, so in this, if you want to get the token, what are the things which are required? So to get the token, the first thing is you require API key. Okay, just a second. Yeah, so we require API key. So how did we get that API key? From here, using IAM, we got the API key. Okay, so you can see here, this is the headers which we have built. API key, headers, payload. Okay, the API key, the headers which are required for calling the token, and this is the token URL. Okay, which we can find it here, the same thing. Okay, once we got the token, from the form node, we are accepting the parameters. We are getting the parameters. Once we got the parameters, we'll be getting the parameters here in this function node, and we'll be using the token with the header, and with the payload we're going to call the API request. Okay, we'll be calling the API request, and we'll be parsing the response. The actual response what we got can be found here, and we found here. Okay, our data is, our actual prediction is present in this place. So I'm just going to parse it. That's what this function node does. Where my actual value is present, I'm going to parse it. I'm going to show it in the text node. Okay, so that's what you see here. So to get this response, okay, what are the headers you require? Headers with content type, this one, application/json, and the token. Okay, so that's what the token, and with these parameters, when you call the endpoint, you'll be getting the response. The response is nothing but your UI which you got. Okay, so the results vary, obviously. That's how we can use the service endpoint. This is your service endpoint which we got. When you deploy your model, each and every user will be getting a unique service endpoint or model endpoint. This endpoint can be used along with this IAM token. With these parameters, we'll be getting the response. Okay, done. So that's it from my side. Okay, so new speaker will be going to join in the next session, the coming session after the break. Jay, are you there?
Yes, Surya, I'm there.
Yeah. I'm done with the session now.
Yeah, maybe you can break for 5 to 3 minutes so that we can come back.
Yeah, you can just take a break of till 6:30. Okay, so Jay will be introducing the new speaker, so he'll be continuing the session. Okay, thank you all.
Yeah. Welcome back to the session. So, dear participants, we have an industry expert who is an eminent speaker in the areas of data science, machine learning, and artificial intelligence, and so on. So, it is our honor to welcome Mr. P. Mohan, senior data scientist at an MNC company in Hyderabad, to our 5th day of GuruCool program. Hope everybody are everybody are back after the break. Yeah. Please respond me in the chat. Yeah, thank you. So, well, it is always an immense pleasure to introduce him. So, Mr. P. Mohan has over 17 years of rich industrial experience in the areas of applied machine learning, artificial intelligence, and big data analytics across various business verticals spanning from manufacturing to banking, insurance to healthcare and retail segments. He's an advisor in data science, ML, and AI at SmartBridge, and chief advisor and knowledge resource at Engineering Staff College of India, Hyderabad. He's a visiting faculty in the areas of data science, machine learning, and AI for the Bharat Heavy Electronics Limited Corporate R&D, Hyderabad. He's a visiting faculty in the areas of big data, ML, AI, in the esteemed institutions of Symbiosis International University, Hyderabad, VIT University, Chennai, and SM University, Chennai. Now I request Mr. P. Mohan to take over the session and transfer his valuable knowledge to our respected participants. Mohan sir, over to you. Thank you.
Okay, fine. Yeah, thank you, Jay. Thank you, SmartBridge, for extending the invitation.
Mohan sir, are you present?
To grace this. Yeah. Can you hear me? Hello, Jay. Can you hear me? Am I audible? Am I audible, Jay? Okay. Thank you. Yeah. Good evening, ladies and gentlemen. Welcome to this evening session on analytical research and data modeling for bridging the gap between academia and industry. I really appreciate the eminent faculty pool who has been attending this wonderful program, GuruCool, hosted by SmartBridge in technology partner IBM. And I hope all of you had some great time on exercising the interesting family of tools in the IBM incorporation. So it's my pleasure to spend the next hour and a half with you all intellectuals on the most happening area in research analytical data modeling practices for academia and industry innovation partnership. Without any further delay, ladies and gentlemen, let me just go into my proceedings with this. I'll just share my screen. Please confirm in your chat whether you can see my presentation or not.
Yes, sir. Able to see.
Yeah. Everybody is able to see the presentation, right? Okay. So I request all the members to remain muted for the next 1 to 1.5 hours. Any queries you can put in the chat. You can type in the chat for an interactive, informative session. At the end of the session, we'll have a one-to-one, possibly with the audience size, and the Q&A session for any further research queries. Thank you, Jay, once again. Thank you, Amar, for introducing me on the SmartBridge. So this is here go. I officially welcome to my technical talk on analytical research for academia industry innovation. The objective of my talk is to enlighten, empower the intellectual pool in creating the next generation researchers. My agenda for the evening with you, ladies and gentlemen, goes like this. I'll be speaking on a small glimpse on the innovative research, overview, motivation towards analytics, a quick overview of the platform that I'm going to discuss hands-on, demonstration with you all. The SPSS modular workbench, a very good innovative product of this era from the wonderful company IBM. Then 2 practical possible use cases for our hands-on exercise, and I would definitely try to put my light on thrust areas of analytical research in 5 industrial segments in the possible time limit. Then we'll end the session with Q&A. This is how my workflow will go with this evening. To begin with, let me just have a motivation factor at the evening time. I think we all been taking a very good solid inputs from the expert speakers in the other sessions. I'll start with this. Dear faculty intellectuals, dear eminent scholars, and the future data magicians of tomorrow, it's a known fact to all of us that this world of innovation, the century era of innovation, has no shortage of ideas and inventions. The only obstacle and challenges we face every day is how we bring them successfully to a market scenario. How can industry, how can organization, how can academics actually make use of this kind of innovative practices in the real world? Hope I'm clear. Is my voice audible, Jai? Am I clear?
Yes, sir, it is fine.
Participants? Fine. Thank you. Now, a comment on research scenario. My dear friends, every one of you who have been lived a life of opportunistic researcher, right from the day that you have enrolled and completed or pursuing, or the day that you want to explore further. To me, research, be it academic or industrial problem solving, I would like to give you some scenarios before I take you all deep dive into analytical research. A group of psychiatric patients are trying to use 3 different therapies to recover from a psychological issue. One goes for a counseling with a doctor, one takes a medication, and one uses a biofeedback. Now the challenge for a researcher is which out of these 3 actually appeals for an effective treatment. This is one scenario where a researcher can actually look into. The second challenge is a manufacturing firm follows 2 different manufacturing approaches for producing light bulbs. Now the production manager might be interested in knowing which out of these 2 processes proves to be better in terms of quality product, a expected lot of production to be achieved, the challenges in the supply chain, and just in time to be achieved. The third scenario, which I pursue as a research from your side, academics, is you all represent different wonderful institutions and universities. Your students from different colleges take the same exam at certain times. Now the challenge here is which college student might outperform the other in order to enter a corporate firm to serve the organization and multiple clients. In all these 3 discussions, my dear friends, if you look at, don't you think all these are the opportunities or everyday problem statements that we can perceive as a research problems? What do you say? You can just respond with yes or no in your chat. These are all obviously the problems of research that you all have been working with, working for, and will always work for in the future also. That's why I pursue research as a careful consideration of a study. Be it any problem in the universe, from any industrial or a business domain, a careful investigation, examination of the problem can be effectively called as research. We all do that using some kind of scientific, mathematical, statistical tools and techniques. But every research must have an outcome. The study that has been taken up by researcher must end at a certain conclusion, arriving at certain facts which might be useful for the future. Now, keeping this in mind, today we have many types of research: fundamental, applied, empirical. Now, from industrial perspective, we always try to transform this into a much better, like innovative research. A new paradigm has entered innovative research. What happens with this? Let us see. As you all know, this era is era of innovation. We need not invent anything new, but we need to innovate continuously. Any idea regarding any product, organization, application, system, technology can be innovated to achieve better outcome of it in order to obtain a satisfy a specific need. Now, on one side, we have the continuously rapidly growing technology practices from the IT sector especially, is there a chance for the academic fraternity, the research intellectual, to keep pace, know these current trends and practices of the industry, be it a framework, be it a technology frontier, whatever it is? Yes, certainly the answer is yes. Academia industry relationships can further be accelerated, enhanced to really club up the knowledge practices of the academic research with the industrial practices. Such a new paradigm really is transforming the fundamental research, which actually emphasizes on the thrust of academia on the basic outcomes like collecting data, interpreting it, and generating a report format, to much advanced research that might be a sustainable practice for many of the industrial problem solving. That's why, my dear friends, today's essence is to emphasize and take you all further with innovative research practices on by combining your fundamental research expertise, your applied research practices, and integrating them with the technology practices, and develop new business model solutions for most of the real world problems, thereby enhancing our social responsibility as a researcher. But you might ask me why I am trying to speak about academic industry innovation. Each one of you might be occupied and been taken up a certain study of your research with your capabilities. I believe in this, the mantra, innovate or die. This is not sufficient still for the current century. We cannot die, but we must still innovate. Otherwise, we'll die. Hence, for a quick business transformation, friends, any organization that is actually outsourcing the research problems to researchers like you must believe in taking the ideas internally from the organization as well as the external ideas from the market to develop successful paths to market innovation. Academia industry innovation is a new paradigm that most of you might be already keeping pace with in your esteemed institutions. Establish analytical centers of research, centers of innovation with R&D, which makes researchers to go one step ahead like a critical thinkers and develop, identify, and define new approaches, thereby transforming ourselves into the next generation researchers. A quick look on what is analytics. Very good buzzword going on nowadays in the industry as well as in academia. As you know, from the long weekdays of back training, analytics is nothing but discovering, identifying, interpreting hidden insights or data patterns that contain a lot of meaning. There are many scientific procedures, data mining being one of the most preliminary investigative methods at its root, establishes the platform for the world of researchers to discover golden insights from volumes of data. Dear participants, hope you are seeing something on the screen. Can anybody tell me raw data, inside the raw data, what you are able to make a guess about it? Those who are able to see the screen can type in the chat. Could you identify something that I have kept inside? Good, very good. Each one of you is trying to answer according to your perception. Some says it's a cycle, bicycle, wheels, some puzzle, unstructured. Very good. Thank you for a quick output. Yes, raw data is always unstructured, voluminous, consisting of varieties within inside it, making it difficult for a researcher, analyst, or even a scientist to understand what actually it is. But through a systematic, careful, and a disciplined approach of research, we could arrive at a certain output by following this. We try to scramble these pieces of puzzle which are spread unstructured, examine these individual pieces of data thoroughly using a process called data exploration. Before we do data exploration, we need to prepare the data for modeling. So we try to separate the data through careful observations and then spend enough time on understanding the individual pieces of the data. After a certain preparation, our data is then ready for analysis and visualization. Data analysis and data visualizations are the heart of any analytical data modeling or statistical data modeling approach, as you already know. after this efforts of the researcher, we finally arrive at an outcome. As I said, research must have an outcome. The outcome of the research might be a very good practical hidden insight. So this is the insight that actually hidden inside the voluminous unstructured data, right? Now the journey is take raw data at the least level, do some kind of systematic data processing, data analysis, modeling approach, arrive at an insight, valuable insight. Now a question, how does analytics relate to research and innovation? How does this analytical practices really help a researcher to go one step ahead and become an innovator of the century? Let us see that. As you see in analytics, right from a simple problem solving to the world's complex data modeling is the ultimate solution. Because it not only provides a descriptive outline of the data in terms of an information report, but it also provides actionable insights which usually lie hidden inside the data. Mostly for business organizations that are seriously in the current world looking for a transformation for sustainability or growth, data-driven analytical practices through thorough evidence and examinations of the research are the order of the day. In order to achieve such heights of knowledge management and intelligence, analytical research is becoming a taxonomy by utilizing several statistical methods like quantitative analysis of the data and much more improved analytical data modeling using the practices of machine learning, artificial intelligence, and big data trends. Now, to keep it simple, how to begin with, most of the industrial research, also the academic, is now shifting towards, have been already shifted to the CRISP model of data mining. Many of you might also be familiar with this, the cross-industry standard process, which is a common framework for many of the industrial problem solving, common approach for many of the industrial problems. It generally has 6 basic phases. A researcher really wants to add more value to develop new innovative models with their expertise. They need to go through the 6 phases. Understand any business thoroughly from its root in its current stature to the future. Collect data related to that business processes of the organization and understand it with enough time on it. With a careful understanding of the data, start preparing your data so that it is suitable for analysis and modeling. Once data is properly modeled with a set of algorithms, tools, and techniques, your model is ready to be tested and for evaluation. Upon a successful evaluation with a satisfactory performance, such models can be deployed into the real world and a production environment. This 6-step common approach framework has become a most important ingredient essential for many of the world's problem solving. So my dear friends, today we keep in pace with this kind of modeling approach. But how to do the CRISP model of data mining for academia industrial problem solving? Now comes the platform. There have been many plethora of tools for research that you might have been working with or already acquainted with. Some of the names in the market leads go, anybody? Python programming, or for statistical modeling, the most phenomenal research tool that many of you researchers have been working with. Very good, Mrs. Akanksha Jaiswal. The undefeated IBM SPSS, statistical package for social sciences. Yes, Veka at the education level, and many more. Stata, the number goes on and on. It's not technology and tool that a researcher must actually be concerned with. It's the framework, it's the methodology of the research that wins. Technology practices are only catalyst. They speed up your research, they add more comfort levels to your research practices. Whatever is the platform, friends, today I take the privilege to speak about this wonderful platform created by the esteemed IBM to introduce all this platform for easy, flexible, and most robust and sophisticated research. The basic essence of choosing this tool in the today's evening session is the SPSS modeler is an extension to the well-known IBM SPSS platform with rich data mining, data modeling, and text analytics practices. That's why it acts as a workbench to build a stream of analytical pipeline that acts on analyzing data, volumes of data from head heterogeneous data sources. The capability lies with this tool is it can work on structured and unstructured data in the real world. And the most important appealing feature is it helps a basic researcher even also to go one step ahead from a statistical modeling to analytical predictive modeling, thereby making you build data-driven predictive models for world's problems. And the richness is it's a graphical user interface like the IBM SPSS statistics tool. This is also icon-based graphical user interface. Now, how to implement this one? This is a sequential step of process. Possibly, I hope all of you can see this slide. Begin with building a stream of data processing nodes that work on appropriate data sets drawn from a problem statement. Once you have suitable data set against a problem statement and you're ready with your hypothetical assumptions, then you go to a second step, define the data types for your fields. Technically, we call these fields as features. Once you define the suitable data types that each field actually fits in with the data, start exploring and visualizing your data. An important step in any kind of predictive analytical modeling is spend enough time on understanding your data, then only move towards building a predictive model. The more time you spend in understanding your data, the better will be your prediction model in terms of performance. Then, once you are understanding your initial basics of your data, partition your data into training and test sets. If required, you can also go for a validation set for strengthening the performance of the model. Then, select a suitable modeling technique. One of the major difficulties that I have been witnessing from the 2 decades of my experience in the research is many of us actually might get confused or struggle or suffer what kind of algorithm, what kind of a statistical test shall apply for what type of data. It can be any test, right? Right from a correlation analysis to a ANOVA or any kind of a statistical test or a regression or a classification. Which data for what type of objective shall be a statistical test be suitable? What do you say, participants? Isn't it or not? How many of us actually get a lot of data volumes every day and we are in a hurry to complete our problem statements by selecting 5 to 6 statistical tests, but do they really make us build a true research outcome? Shall that research be applied in industry for problem solving? Yes, my dear friends, this is a common problem to every one of us. That's why this tool has got a different working fashion. It allows you to choose your required algorithm for your data sets to satisfy the research objectives. Or if you're a beginner who doesn't have any glimpse of the statistical approaches, it allows you to run any algorithm by default. It runs, it needs to run 15 different machine learning algorithms for any kind of data set and allowing you to choose the best 3 or best 4 or best 5 novel models that really work, that fit for your data. Now, the training and test sets and validation, which I was commenting, are nothing but volumes of data before carrying forward for research data modeling must be broken down in order to understand the initial characteristics. Statistical researchers call this as a sample for your information. From a population, you draw a suitable sample with certain sampling techniques that make the data ready to undergo the statistical data model. Analytical modeling or predictive analytical modeling allows you to divide your data into 2 major partitions, a training data set, which comprises a major significant portion of your data that the algorithm actually understands the patterns upon which generates predictions and validates them on the test data. Once a suitable modeling technique is applied, we generate the output, that is the prediction. We evaluate it against the new data, the unseen test data. If the model or the models perform well, we are ready to release those models for real-world deployment. If required, you can extend the workflow in the stream by adding more nodes, processing nodes. At the outset, this is the sequential stepwise implementation of the SPSS model. Now, without any further delay, let's go into our hands-on session. I'll be speaking on the stream introduction. I'll be switching between the cloud platform and the stream. Okay. Right. I'll be just starting my use case one. My first use case with you all hands-on is impact of demographics on sales performance. So I'd like a small data set and a case study to show you how to do a predictive analytical research with this data set. A business firm is actually operating by selling its products in 3 different locations, namely Hyderabad, Bangalore, and Mumbai. The firm's sales manager wants to understand whether the demographic variables in the research problem how are they going to affect the target, that is the sales. In order to understand this problem through a predictive analytical research, the sales manager tries to explore and analyze various data dependencies. In a journey, he conducts several statistical analysis, explores the data, visualizes, and at the end, also tries to build a predictive model. Okay. Hope all of you are now live on the cloud. Let me know, IBM Cloud. Dear participants who are able to work parallelly, you can work. I hope Team SmartBridge has already shared with you some data sets, namely sales.csv. Please download that sales.csv and keep it on your machine for ready to do a hands-on. Right. Now I'm just shifting to my thing. Let me just keep it aside. Okay. Let me add some tab. Yeah. Let me just keep it aside. Right. Is it let me just take another tab. Yeah. I'm just logging into my IBM Cloud account given to me. Cloud.ibm.com. Participants, can you see my browser application? Please remain in the chat active. Can you all see my browser, ladies and gentlemen? Okay, let me share that. Yeah. I'll just share my screen. Hope you can see it now, right? Yeah, fine. Good. Fantastic. We'll go slow a bit. I request everybody to open your IBM Cloud application. Ladies and gentlemen, please go step by step at a time. Cloud.ibm.com. If somebody is already logged in, don't worry. Stay there. I'm just logging in with my IBM allotted IBM ID from SmartBridge. Click continue, click login. So this takes a couple of seconds, minutes. Yes, I'm done. Can you see my dashboard? Please confirm. Is it visible? Or else I just share my screen. Thank you. Thank you for the quick introduction. This is my dashboard of the logged in account. Hope you're also, everybody is here. I request all the faculty pool to stay on their respective dashboards of the accounts. From here on, we'll start the hands-on session. Click your services hyperlink in the dashboard. Click your services entity, all of you. I repeat, all of you be in the dashboard. Can you all locate the services entity? Yes, click that. I think you have been working with various services in your resource manager dashboard from the last few days, right? Okay. Let me know, every one of you have an access to this service, Watson Studio. Please confirm. Every one of you have actually added the service named Watson Studio to your resource manager. Thank you, participants. Thank you. I hope you have been working with this in the last session. Thank you. Click Watson Studio in the services list, in the resources list. Click Watson Studio in the services list. Right. Okay. Now, decrease my screen size so that you can see that. Can you all see a Get Started button? Hope you all notice a Get Started button in your Watson Studio. Please click Get Started. Request all the audience to click on Get Started on Watson Studio. So this will navigate us to the IBM Cloud Pack for data. Once everybody, majority of you, all of you are at the screen, please confirm. I'll take you all one step ahead from here on. Yeah, this is the dashboard, my user account on the Watson Studio. Fine, good. On your left side, on the quick navigation pane, please identify projects. Hope all of you can see at your IBM Cloud Pack on the left side. Yeah, I'll wait. Okay. On the projects. Please confirm everybody so that we'll all go at the same pace. Good, fantastic. Nice synchronization. Good. I request, okay, don't worry, Venkatesh, you can just keep pace with this thing. Okay, fine. Good. So those who are already reached till here, I request all the participants to just click on the projects. Click on the projects hyperlink, and those on journey, please avoid. Don't worry, the session is on recording, that will be shared. So click projects. Yeah. So now you navigate to the projects dashboard or the window, application window. Hope everybody is here. Let me know. Please confirm in the chat. Dear faculty. Thank you. Good. That's marvelous. Great. I hope every one of you could successfully navigate until this web page. Now, on your right side, notice a new project button is there where I'm hovering the mouse. All of you notice you have a new project button. Please click the new project button where we will add all our project resources like data assets, workflow streams. So click new project button. Click new project button on the extreme right. Now you are in the web page called create a project, right? Yeah. And below you have certain options. You can see create an empty project or create a project from a sample or a file. So because we are beginners, we are at the scratch. Let's go from the scratch. Let's create an empty project. So I request all the audience members to please click on create an empty project. Create an empty project. Now participants, I hope you are now in the new project page. Please confirm. Everybody, those are able to navigate, those are able to maintain the internet speed equally with me. Please, others, those who are not able to keep pace, don't worry, ladies and gentlemen. This session is recorded at an interactive pace. Thank you. New project. Now, let us provide the project details. As I briefed you in my presentation, the case study is about what? Analyzing the impact of demographics on sales. A company is trying to sell its products at 3 regions. They are hiring sales executives. Sales executives have certain demographic features like gender, the region in which they are selling, their age, right? Like this. So I am naming my project as demographic. You might use other titles of your choice, but for this project, I'm recommending demographic impact on sales. Demographic impact on sales. For a better thing, you can use hyphens also for a readability. Yes, on sales. So this is my project title. I am defining it here. You can add a small description if required. This project aims at analyzing the demographic impact on sales performance. Sales performance of the company. So this can be added, it's optional. So request all the members to define your title of your choice. For the current project on sales data, we are going to assess the demographic impact. So request all the members to plug in these two inputs. And please ensure your object storage, the models, the project which you are building on the right side. Please notice by default, IBM Cloud maintains a cloud object storage repository consisting of all your project assets inside it. This is the project object storage explorer. Can you all see this on the right side? Storage explorer is your COS, shortly, cloud object storage, COS, technically. So those who have plugged in the title and the description, and all others, I request do this, and please click create button at the bottom. Please click create. So this takes a few seconds to do this. So what I got, unable to configure. Same storage instance is there. So I have already created it. So I just would like to change the name, demographic analysis on sales. So don't worry, you can create that. I already created with the same instance. That's why it's not overriding. I'll change my project title. Now it will be created. Demographic analysis on sales. So let me know. Yeah, this is created. Did you all get this? Participants, please confirm. Did your project page is created successfully? Very good. Thank you. Right. Now we are in a quick hurry to create our workbench. That is the stream pipeline for our workflow. Good. Can you all see at the top of your dashboard, you have a blue colored button, add to project. Add to project, right? You have a button, blue colored, highlighted, add to project. Request all the members to please click add to project button. Please click add to project. Now comes different assets in the IBM Cloud Platform for you to add, starting from your raw data, from a connection to a data sources with different platforms that you have been working these days. Now, our job is first what? Add the data set, appropriate data set related to our research. So can you all see the asset type dialog? Hope the asset type dialog is visible to all the participants. Please choose data, the first object, first asset object, data. So click data. Please click data. I request all the members to click data. Now, once chosen, what did you notice on the right side? The cloud platform is requesting you, please load your data file. On the right side of the dialog, you can see on the page data. And you can also see a message, drop files here or browse the files to upload. Could you all see on your respective pages? Dear faculty? Good, great. Great, appreciate your concentration and the parallel navigations. Now I request all our esteemed audience to click on the browse link on the right side. You will notice a browse link. Click browse link. Immediately the file explorer opens on your machine. I have been already using a data set for this project called sales.csv. Hope this data set was shared to you by the project host. Let me know. Good, great. Wherever it is, please browse that appropriate file, whether you have downloaded on desktop or whether you have downloaded on downloads folder, wherever it is. Request all the members to navigate to the respective folder and select the file named sales. Select the file named sales and click open. And click open. You need to stay on this page for a few seconds until the application confirms that the file confirms that the file is uploaded, right? You can see the user convenience message, stay on the page until the upload completes. So those who did not receive file, sir, please collect it after the training program. Yeah. Those who have collected, Data dialog on right side. You can see I'm closing the data dialog. Now we have successfully uploaded our data, research data for analytical modeling, right? Are you all clear till here? Let me know. Hope everybody is clear till this point. Thank you. Good. Now our next step in the workbench in the IBM SPSS modeler. Again, click on the add to project button because we need to add assets to our workbench. Again, I request all the members to click add to project button. And once again, be on the assets page. And this time, the application environment that we are going to use from this cloud platform is IBM SPSS Modeler Flow. Could you all locate this on your respective machines? Click on Add to Project and choose asset type as Modeler Flow. Right? So I request you all to click on Modeler Flow. Click IBM SPSS Modeler Flow. Now here are at your one of the most fascinating tools for researchers of this century, IBM SPSS Modeler Flow. A highly graphical user interactive interface for building quick streaming workflow analytics for many of the real world research problems. Let me please know from you all, are you at this web page, participants, new modeler flow? Everyone, those who are actually working parallelly, those who are unable to follow here, don't worry, once again, this will be shared to you. Good. Now it's time for us to name the modeler. Last time we named our project. Now in the project, the first asset is data. The second asset is the workflow of the modeler. Let us name. I just said the nature, the project title which we are working today is demographic analysis, right? On the sales performance. So I would like to keep my modeler title, project modeler title as sales performance analysis. You can choose any of your name, but ensure that the title suits to your project workflow. Sales performance analysis. We are interested in analyzing the sales performance today. So you can give a suitable title like this. The description is optional here. Right. Sales performance analysis. Right. Okay. If you're a beginner and don't know how to go ahead with this modeler, there are other alternative ways. You can start from example. I hope you can see the tab on your screen also. There is one tab given here from example that is already a predefined data set. A workflow model has been created in the cloud platform for beginners to understand. Or if you are an intermediate user who already had some hands-on experience, you can begin from a file. If you're an advanced user and want to do the real-time execution workflow, you can start building completely a new project from the scratch. So I hope everybody is done till here. Sales performance analysis, right? Okay. Click create. Now the workflow workbench now appears with all possible tools with appropriate nodes on the left pane. Now the new modular flow is working. So this takes few seconds. Contact your cluster administrator. I think you have been using, Madam Lakshmi Sri, you have been using the application tool, might be in connectivity with the modeler might have been not resolved. You can restart from the scratch, madam, not an issue. Yeah. Okay. How many of you? Okay, fine, good. Most of you are getting that issue. Could anyone get this page? Let me know. Anybody? Could anyone see what I got? The modeler workflow. Those participants who could not come to this page, don't worry. You can relog in again into the cloud platform because the application might be idle from the last session to this session. Don't worry, you can relog in and follow the same navigation. If the cluster resources are limited on that account, you need to get the permissions for that account, ladies and gentlemen. The account provision administrator will grant those permissions for further access, don't worry. But for a login credential, these are the minimum things that are actually permissible. Yeah, right. Okay, those who are actually facing difficulty, don't worry, but those at least who got access to this thing, please continue with the navigation. Others can watch. Those participants who are still got this web page, now we are ready to build our workbench with the dataset sales.csv. Right. Okay, fine. Now, can you all see the options on the left pane? Import, record operations, field operations, do predictive modeling, perform text analytics. A collection of plethora of tools are there on your left pane on this workflow modeler platform. Our first step is we need to import the data into the IBM SPSS modeler platform, right? I request you all to click on the import link. Please click import. Request you all to please click import, right? Okay. Done. So what is the first option in the import? You notice data asset, right? Can you all notice that under the import drop down, we have the first option, data asset, because this is where we have to build our research models from. So drag and drop data asset from the panel to the workbench. This is the workbench. Get started. The label get started shows the workbench of the modeler platform, and all analytical data nodes assets are available here. So pull out your data asset, drag and drop it in the workbench. Participants, hope you are able to understand my workflow. Once again, I'm discussing. On the import drop down, click import, select, press and hold on your left mouse button, drag the data asset and drop it in the workbench. Could you all do that? Let me know. Yes, good. Right. Now we have the data asset pulled in over here. Just place your mouse pointer on it. Just move your mouse pointer. Could you see the 3 dots on top of it? 3 ellipses are appearing here with the arrow. Could you all see that? When you move your mouse pointer on the data set processing node, just click the 3 drop downs. Click the 3 drop downs and choose preview option and click preview. Click preview. Once again, I am briefing for the first project. Move your mouse pointer on the 3 ellipses. Click a pop-up shortcut menu appears and choose what option? Preview. Okay, still there are no records fetched. Yeah, okay, right. Now there is no preview because we didn't connect the data set. What data set we are using? Sales.csv. We need to connect the sales.csv to this data set. So click it and say open. Click on the 3 ellipses and this time you choose the open option and choose open. On the right side, you can see the data set dialog and 2 options are there. Change data set, refresh. Could you all notice that? Change data set and refresh. Right? Now, once again, I'm showing for anybody who is having any difficulty. After dragging the data set, right click or click on the 3 ellipses, choose open. And here you choose change data asset button. You click on change data asset. All of you click change data asset button. Right. This will take you to the project assets web page. Now your project title is visible. I hope my project title I used as demographic analysis on sales. Are you all in this page? Let me know from your side. I think few of you have reached this page at least. Good. Others are trying to navigate. Good. On this demographic analysis page, can you see one option is there, data assets. Could you find that where I am hovering the mouse? Yes, data assets. Please click data assets. Please click data assets. For this project, for predictive modeling, what is our data set, participants? The data set is sales.csv. This is the data set. Hope all of you could locate your sales.csv file. Right? So please select or click on data set assets sales.csv. Please select sales.csv as your asset for predictive modeling on your machine. And at the bottom, click OK button. Click OK. Right? Choosing the assets, select the required asset, that is the data set that is uploaded, and click OK. Done. Now, on the right side, you are now noticing the source file. Would you all notice on your right side? The name of the source file for predictive modeling in the project is what? Sales.csv. It's a comma separated delimited file. The nature of the file is described by the platform, modeler platform. Fields are separated by a double quotation mark or a period, anything you can use. And these are the default. The tool has captured the nature of the data. Can you see the save button at the bottom? Everybody, please click save button at the bottom. Yeah, I just click save button at the bottom. All of you click save button at the bottom. Takes a few seconds to connect the asset to the data source. Now participants, could you see the name of the data asset is now sales.csv. This is the first step. Connect to your data source. This is a very simple data source. But in real world research, you might be working on several data sources. That is heterogeneous, multiple data sources also, right? Import all your data sources, and inside the platform under the field operations, if you see under field operations, let me just say, or the record operations, see, import multiple files. If your data is located in multiple files, participants, import them one by one, add them to the data set, and you have an option, merge. Where is it? It is under record operations. Under record operations, you have a merge operation also. When you drag merge operation, IBM SPSS modeler combines all data from heterogeneous data formats, right? But please make sure that all those file formats are same. For example, if you want to combine the data from two different CSV files, ensure both are CSV files, because data comes from a flat file or a relational data source or a warehouse also. So for this step, I'm not using the merge because I'm working on a single data source, right? Hope everybody's done till here. Now click on the three ellipses, and now you click preview option, which we were doing. We can import Excel file also, Madam Akanksha. We can import Excel file. We can import text files. We can import Oracle SQL tables, MySQL tables, flat files. Anything is possible with this platform. Universe of sources can be analyzed using this wonderful SPSS IBM modeler. Right? Okay. Then I request you all to preview your data. Just preview your data. You'll get a short preview table of the sales data on your machine. Preview represents few rows of the data. If the data set is small, all observations are displayed. But if the data set is voluminous, few sample rows are displayed. It takes some time to get displayed. So those who got the preview can view it. Mine is loading. You'll get a short preview table of the sales data on your machine. And it's taking some time. Preview represents few rows of the data. If the data set is small, all observations are displayed. But so this is a cloud platform, and we are working on a WebEx meeting. So this might consume several bytes of internet based on the speed, access speed. Right. So those who got the table, I request you all to go through that data. What are the fields inside that, ladies and gentlemen? The sales executive name, the ID, the gender, the location, age, and the sale value. These are the parameters of research for the data set which are visible, I think, on your side, right? I think my preview was not loaded. Sorry for that, for the slow internet speed on my side, but I request you to view it on your side. Okay. So those are the data points. I once again read it out for a benefit of. Thank you. Wonderful for that sharing. Sales executive, name, gender, age, location, sales in rupees. These are the data fields which are available under this data set, right? Okay, fine. Hope all of you understood till here. Now the next step, for any research to be to model the data effectively in order to bring better interpretation reports or further develop predictive models with any of the, yeah, you can close the preview, madam. Please close the preview after viewing it. Now the next step I'm speaking about, all those who have been in the preview dialog, please close the preview dialog box or the window and come back to your modeler platform. Be in the modeler screen, workbench. The next step is we need to define the data types of the fields. We need to specify appropriate data types. By default, modeler is an intelligent tool. It tries to sense the nature of the data based on the values of the data fields. So for this to happen, click on field operations in your left panel. After connecting the data to the set, the next step is watch the navigation carefully. You have field operations on your left side, right? So please click field operations, all of you. After closing the preview dialog, please click on field operations. Can you notice a node called type? Can you all see the node name type? Everybody? Yes. Drag the node type and drop it in the workbench. Drag the node name type and drop it in the workbench. Right? Good. Hope all of you can now see your type node in your workbench interface on your machines. Right? Okay. Good. Now, place your mouse pointer on the sales.csv file once again. Just move your mouse pointer on sales.csv. Can you see a blue color arrow? Can you see a blue color arrow? Everybody, while you place your mouse pointer, correct. Click on that and drag a line. Click on and drag a line and connect it to the type node. Click the blue color line arrow, drag it and connect it to the type node. And then drop the arrow. Leave the mouse. Can you see an arrow extended between the data set and the type? This is called pipeline. Yeah, the workflow pipeline. Technically, we call it as the workflow pipeline in the workbench. Hope all of you could drag it again, right? It's very simple. Just press and hold down the blue arrow key and just drag it. Okay. If it is not showing sales.csv, Madam Bhagyasri, don't worry. You, I think, could not connect the data set correctly to the data set, right? So what you do is, this is for Madam Bhagyasri actually. Right click and open the data set and click change data set, madam. Click change data set. Okay, are you able to follow? Change data set. Connect the sales.csv there. Yeah, good. Right. Now, I hope all of you could connect the type node to it, sales.csv type node to it. Now, on the type node, do the same navigation like we did on the dataset node. Click on the 3 ellipses button. Click the 3 ellipses button on top and click open. Click on the 3 ellipses button and click open. Now, let me know how many of you got the data type dialog box. After inserting the type node, I request you all to click on the 3 ellipses button and choose open. Now you got the variable names, field names, what type of measure it is. In statistical data analysis, most of you might be aware, variables are of different types: continuous variables, categorical variables, nominal, ordinal, and SPSS also adds one more variable type called flag. The flag type. I'll be briefing on that. A good appeal of this feature is you can see the field name, its measure, the role that the field plays, It's in a value mode. Whether they contain any null values or erroneous values or outliers, everything is displayed in this type dialog box. Okay. Now, from our data set, those who have previewed, I'm saying, those participants who could preview it, tell me, participants, sales executive, the first column, what did you see in that column? Does that column contain numeric values? It is the ID. The first column in this data set is salesman ID or sales executive ID. Unique values are there. 1, 2, 3, 4, 5 till 20. 20 salespersons were there in the data set. So which type of measure is this field? Anybody? You can see on the measure. It's a numeric data, right? SPSS statistics or SPSS modeler understands this data as a continuous data field or a continuous variable, right? So by default, it is continuous. You also have the privilege to click the drop down and change the variable type also. Make sure that you select the appropriate type. By default, the modeler shows the appropriate type, no need to change it. But if you want to further modify the data type, you are welcome to change this data type by clicking the drop down and change it. But make sure you select the appropriate data type. Correct, sir. Madam Akanksha, you're absolutely right. In SPSS, you need to specify that fields. But here the modeler is able to sense this, right? That's the benefit, dear researchers. The model is able to make the sense out of the data based on the nature. Obviously, you're right. Correct. Now the next one, I think this is loading again. Don't worry. Some statistical tools needs the researcher to explicitly specify the nature of the data, but that's not the case in SPSS modeler. So this is a bit loading again. Right. I'll just go back and open my data type dialog. Right. I'm here. Now, what about the sales executive name? Sales executive names, right? There are some names. So the modeler is telling us it is a categorical, right? So what do you feel, participants? Is it categorical? Really? No. Very good answer, Dr. Meenakshi. It's a nominal variable. This is where practices of research, knowledge of the basic data understanding is essential for researcher. Nominal variable. It's not categorical, right? Good. Thank you for the input shared on the chat. Good. Please change, everybody change the data type of sales executive from default categorical to nominal on your side also. Done? Is it done? Right. Now, coming to the gender. Is gender a categorical variable? What do you feel? Yes, it is a category consisting of two binary labels, that is male and female. So leave it turned. But my dear friends, there is one specification that you all should understand. Whenever you are modeling, when you are building a predictive model on a certain data, human understands that gender is a categorical variable with labels as male and female. But a machine powered by computing algorithms behind working on data might not understand it during modeling. It might so happen that the algorithm or the model, due to unable to understand the nature of data, might ignore this variable not to be included in the model. Might, due to the irrelevant understanding of the variable or the field, the model might skip this variable and it might not be included in the model. Don't you think gender of a salesperson might have any impact on sale value? What do you say? How many of you do you think that the gender of a salesperson might also have certain partial significance impact? If you believe that, please change this categorical variable to a flag variable. A flag variable is usually a binary in nature, which tries to examine, which allows a predictive model to equally consider these flag variable categories like a male. How does a male gender impact the sales outcome? How does a female gender impact the sales outcome? Right? So I request you all to change the measure of the gender from a categorical to flag in this case. It can also be categorical also initially. But for effective performance of the predictive model in terms of accuracy and prediction management, please change it to flag here. Yeah, let me know. Have you all changed it? Right. Good, great. The next variable, age. Age is a continuous variable. It's numeric and a continuous predictor. Right. Location. I said the company is operating in 3 locations. What are they? Could anybody notice that in the preview? The company is selling the product in 3 locations: Hyderabad, Bangalore, and Mumbai. There is no particular order of these categories. So, shall we go with a nominal? Yes, we can go with a categorical or a nominal variable also. But herewith, I'll go with a nominal variable. There are 3 categories of locations, but you can still change it to nominal categorical. Now, finally, our variable sales in rupees. I hope sales in rupees. Yeah, we have 6 scales. The nature of the this tool is it tries you to define the nature of the data in much more advanced formats. There is a succinct differences that lie between nominal, ordinal, continuous, categorical, right? Usually, gender is a categorical variable. Razak ji, gender is a categorical from its basic nature, right? But what I'm telling to tell is, if you build a predictive model by including gender as a predictor, significant predictor, sometimes it may so happen that the predictive model, due to its inability to model the test data on the predictor, might ignore it. Now, don't you think losing a field, losing a predictor from a model might result in some low performance? It might end up in developing a predictive model in a low performance. In order to not to let that happen, we are trying to describe the gender categories as a binary flag. From the language of computing, a flag variable is usually a variable which has a binary value like 0 and 1, representing certain states of the data like true or false, yes or no, like that. So the model cannot ignore such variables also and might include it as one of the predictor. That's the reason why SPSS modeler trying to show different additional measures which otherwise are not available in SPSS statistics, which most of you might have worked in your past. Right. Now our output variable is sales in rupees, right? Do you all agree? It's a continuous variable. After defining the measures, friends, now it's time to define the roles of the fields. From your observation, from your experience of research, can anybody tell me in this project, what is the outcome variable or the target variable that we are trying to explore? What is the output? Thank you, Madam Lakshmi Sri. Thank you, everyone. Sales in rupees. Fantastic. Sales in rupees. So by default, SPSS modeler defines all variables to be input roles. All of them are input. At least one variable shall be output. Such a type of predictive modeling is called supervised or a supervised machine learning or predictive modeling, where you have a definite target to achieve based on the relationship with set of predictors. So let us change the role of sales in rupees from input. So last variable, I request all the participants to change the nature of the sales in rupees variable from default input to target. Change it to target, sir, everybody. Ladies and gentlemen, please change the nature of the sales in rupees role to target. Let all others be input predictors. Let all other fields, our research parameters in the model, be inputs by default. Hope all of you have done till here, right? Good. Now, if you scroll a bit upwards on the data type screen, can you see one button, read values? After setting the measures and the roles, can you see one button, read values, right? Now, before clicking read values, before I click read values, carefully observe the column value mode. In the value mode, by default, SPSS modeler is using the read permission. You can see all variables are being read into the workflow workbench. When I click read values button, immediately SPSS modeler will capture the values of continuous variables, nominal variables, flag variables. If it is a continuous variable, participants, yeah, it is instantiated. Correct word. The reading process is instantiated. For a continuous variable, you will get the minimums and maximums. For a flag variable, you will get zeros and ones. Okay, let's see that. So the workflow is again opening because I kept the platform idle for a few seconds. So I request all of you to click read values button on your side and tell me what happened there. All of you can click on the read values on your side. So even I do the read values button click, processing takes place and the instantiation, reading of the values gets started. Why the data gets read? That's it, simple. Yeah, values are appearing. Okay, right. So all value mode is instantiated. Yeah. So I can see the sales executives starting from ID 1 to 20, that is 20 sales executives are there in the company. And the nominal variable names are appearing. Few names you can see. The gender flag is in this thing, female and male. Okay. And my continuous variable, can anybody tell me about the last value 11,77? Anybody take a chance? 11,77. What do you mean by that 11,77? Fantastic answer, Madam Kriti. They are the minimum and maximum values for that field. Descriptive statistics of the data appear here. Your basic statistics, the central tendency measures might appear here. Lowest and highest values appear here. Right? Now, after doing this, your age values are 19 and 300. No, it can be 19 and 30 because the data itself has 30, madam. So once again, click read values, Madam Akanksha. Okay. So I have 19 and 30. Is this in the database? Okay. If it is there in 300, not an issue because the data set which might be shared might have at least one record with 300. Not an issue, will accept it. It's a typo error, right? Maybe that will also be used for analysis, right? Correctly said. The data set which I might be using might have 1930, but what was shared to might have a 19 and 300. Don't worry. Consider it, madam. Consider it, sir. Not an issue. Just click save button. With this done, just click save button. Yeah. Done. Now we have defined the data types, right? Hope everybody is still clear till here in the workbench. Let me know. Defining the data types, measures, roles, and accepting it. Timed out. The session is getting timed out. Not an issue. Done. I hope all of you are done till here. Okay. Good. Now it's time to go ahead further a step ahead in the workbench. Click field operations. Click field operations once again. I request all the participants to use field operations once again. And on the field operations, could you notice one node is there, auto data preparation. The first one, auto data preparation. Would you notice that, everybody? Please now drag the node named auto data preparation and drop it in the workbench. And drop it in the workbench. Done? Is it done? Auto data preparation is the next node in the workflow pipeline. Now, what this means is those research practitioners, research enthusiasts who have been working with IBM SPSS statistics during these days, if you all remember, data recoding is one of the most important prerequisite step in data pre-processing. A data set is a rich composition of continuous variables and categorical variables also. Any statistical tool is capable of applying its statistical functions on numerical data. But do statistical functions, mathematical functions, do you think will work on categorical data? Can I find a maximum of gender? What do you say? Is it possible for us to find maximum of gender? No. But it is possible for us to find maximum of sales, maximum of age. Continuous variables are well suited for statistical evaluation and analysis. But should we ignore the categorical variables? Don't you think categorical variables also has certain impact on the outcome target? Right. Then how to handle these categories of data and include them in predictive model? A prerequisite step is do data recoding transformation. For that, we are using auto data preparation. Unlike in IBM SPSS, here in SPSS modeler, this node auto data preparation automatically recodes your categories into numerics. I repeat, just by dragging your auto data preparation node, the categorical variables in your respective data set used in the project undergo encoding or data recoding automatically by the modeler. Whereas in IBM SPSS, aren't you transforming the data manually by yourself or not? What do you say? Right? You have to do recoding. You have to go to the transform menu in IBM SPSS and then add labels and values, new value, old value, you have to tell, and then you have to accept this, right? But whereas this automatically happens. Hope all of you added this node, right? Now, after adding this node, please click on the 3 ellipses button again and choose open. And notice the auto data preparation dialog box fields are available for you to customize. You can edit this if required or leave it default, not necessary at this stage. You can define objectives why you are recoding. Let me know from you researchers why data recoding is done in any research data modeling project or practice. Why do you record the data, ladies and gentlemen? Anybody? Fantastic answer. Normalization. Very great answer. Better optimization. Good. Excellent. See, the objective of researcher is to bring out a best model that addresses the that can explain how an outcome is affected by set of parameters. It should not so happen that the model should not outmine or ignore some of the parameters due to the nature of the data. That's why to feed the data to a statistical tool, it is always recommended before modeling to recode the data or transform the data. Thank you for sharing your research insights and experience. Good. So we will take this as an important step as during data pre-processing in the predictive modeling framework. Leave this as it is. Auto data is recoded. So open it and click save. Save it. The data is recoded automatically. Right? Now the next step, participants. In the data pre-processing step, one of the most important one is partitioning your data. Partitioning the data into training and test set so that we can build our predictive model on training, make it learn the patterns in the training data set, evaluate those predictions on test data partition, and then measure the performance characteristics like accuracy and others. In order to do this thing, add partition node, click field operations, once again, and scroll down and find a node named partition. Find a node named partition. Could you all locate that partition node? Please confirm in the chat. After adding auto data preparation, the entire data is recoded for your information in the background. And drag partition node and drop it in the workbench. Drop it in the workbench. Yeah, please drag it, madam, after you found it. Ensure the workflow, how you are following. Okay, ensure the workflow. I just forgot to add the workflow here. For each level, drag the arrow and connect it to the next node. For each level, drag the arrow, connect to the next node. Ensure the pipeline follows. Connect the previous node to the next node. Make sure all participants connect all the nodes one after the other. Hope all of you added the partition node. Let me know. Thank you. Great. Now, click on the 3 ellipses on the partition. Click on the 3 ellipses on the partition. Okay. Madam, you're working on the cloud platform on a meeting. So based on your internet speed, that might take a bit slow. Don't worry, Madam Bhona. Once you get access to the panel, slowly drag and drop it. Okay. Done. I request all the members who have added the partition node, click on the three ellipses, click open and go to the settings dialog box. On the right side, could you see the settings dialog box? Those who added the partition and right click. Now leave the default partition name as partition, or you can type in your required name also. So the partition is actually an entity which is holding two partitions, namely training as one partition and testing as one partition. Yeah. Okay. Now the training partition, by default, the modeler shows 50% of the data goes for training partition and 50% goes for testing partition. For this project, you can change this allocation to 60-40. So change the partition. Let training data set hold 60% of your data and testing partition hold 40%. So these partition types are also dependent on the industrial problem statement. For marketing, market research projects, we do a 60-40, 70-30. For mission critical projects like healthcare, bank fraud detection, we do 80-20. For much more mission critical projects involving robotic applications, space satellite, geospatial, we do a 90-10, so that better patterns can be learned. For this project, I request all our participants to use a partition split of how much? You can also use 50 and 50 default, but it is better to allocate more observations for training so that the model learns the patterns to a greater extent. So please choose 60-40 on your side also. Is it done? 60 for training and 40 for testing. Yeah, 60 for training and 40 for testing. Here I'm using only two splits, training and testing, but for a better model building, you can also add a validation set also. For this project, I am not using any validation set. Just for an introductory session, I'm using training and test. If required, you can also make the model more sophisticated by creating a validation also, right? And let the seed be a random number generator so that in each iteration, random rows of observations are allocated to training and test. The default seed is a random number generator. Click save. Yeah. Once again, on the partition, click open. In the auto data, in the auto data, no need to fill anything, Madam Meenakshi. Leave it as it is, madam. Just add the node and click save. Okay. Test data set is actually partitioned from the original data set only. How many observations are there, Krishnam Raju? In your data set, 20 observations are there, sir. From that 20 observations, only 60% is the training, 40% is the testing, right? 60% of 20 means how much? 60% of 20, sir. Very good answer. 12 observations are allocated to training data set, and the remaining 40%, that is 8 observations, are given to test data set. Are you clear, Professor Krishnam Raju? Yeah. Yes, correct. This is how I'm splitting it. Click save. You can also do 70-30 also. Good. Hope all of you added the partition, right? Now it's time to finally add our modeling algorithm, build a modeling algorithm, right? Now tell me, yeah, it will take 60% randomly, sir. If you want, you can just go ahead, right click and choose preview on your partition. To view the data preview, Professor Mahinder, you can choose right click on your partition and choose preview. All the participants click preview and view the data. Based on the volumes of the data set, more random sampling will be done. Here for a demonstration, we are using a very small tiny sample data set with 20 observations only. But always research volumes, as you know, the sample based on your problem you're addressing. Yeah, you can just see here. Can you all see the preview? Everybody? Yes. You can see, sir. Now on the right side, scroll towards right side. A new field is added to your data set, partition. Could you all notice in your preview? Scroll towards right side. Move your scroll bar towards right side and you notice a new field, partition. One observation is moved into the training, named 1_training means that observation fits in training data set. Similarly, you can see one observation is moved to the test data set. Likewise, training and test data observations have been partitioned. Professor Krishnamrazu, I will be answering your question, novelty of the model, in the Q&A. Can you wait for a few minutes, sir? Yeah. Okay, that's a very good question. Just wait for a few more minutes. That's it. You'll get your answer. Hope all of you understood till here. Right. Now, the final one. Keep the thing simple. Modeling. Click on modeling tab. Click modeling tab on the left pane. Now, participants tell me, our goal in this project is to analyze the impact of demographics like gender, age, location on our target variable, that is sales. Is the target variable a continuous variable or a categorical variable? In this case, it's a continuous variable, right? From the language of statistics, if you want to model an outcome variable which is continuous, what is that statistical technique that you people apply? Fantastic answer. Regression analysis, right? Whenever you want to model an outcome variable of continuous type, a suitable is predictive regression. Similarly, when our outcome variable is categorical in nature, either binomial categorical, multinomial categorical, then we go for a classification problem, right? These are all the basics that you all intellectual already know. Good. Now, on the modeling pane, if you can see, several algorithms IBM SPSS modeler is actually comprising of. These are all the machine learning algorithms or predictive modeling algorithms which are available. You can pick up a linear regression algorithm if you want. You can pick up a linear regression algorithm. You can scroll down, sir, ladies and gentlemen, scroll down on the modeling. Linear. A simple linear regression tries to fit a model between a predictor and a target. If you have one predictor and a target, you can go for this, or you can also go for a multiple regression analysis also. Multiple regression analysis. Imagine a beginner doesn't know which algorithm to apply. Because some of you have been proven research experience and expertise, I really congratulate for that knowledge horizon. But if I don't know, imagine if you're all beginners, then how to go ahead at this stage? Now scroll up. On the modeling, can you see one option, auto numeric? All of you, please locate one algorithm, sir, auto numeric. Could you all find it on the pane? Yes. For a basic researcher who doesn't know which type of algorithm, which type of statistical test to apply for a particular problem statement data, I request you, please select auto numeric mode and drop it in the workbench. And drop it in the workbench. At this point, it is evident that we must do a regression analysis, but I don't know which statistical test really opts me, really suits me for this data. So I go ahead with the auto numeric modeling platform, right? By default, whenever you choose auto numeric for a continuous outcome, auto classifier, you can also see one more algorithm is there, auto classifier. When should you choose this? When your outcome variable is categorical in nature, then only you should choose this. But when your variable is numeric or continuous, choose auto numeric if you don't know which algorithm really suits better to our outcome variable. So choose auto numeric and click open. Before doing this, please connect the the workflow pipeline. Please connect from partition to your auto numeric. Currently, there are no targets defined. Target variable has not been defined yet. We will define the target here. Hope all of you added auto numeric. Please confirm in the chat, ladies and gentlemen. Just a few minutes left over to make you all feel the pleasure of analytical predictive modeling with IBM SPSS modeler. So please stay for a few minutes. Yeah. Yes, you will get sales in rupees, sir, actually. See, did the algorithm identify the target variable or not? It identified. I'll define it here, but for your case, it identified. That's the intelligence this tool has got. Yeah, it automatically shows, madam. Don't worry. The algorithm is able to sense the outcome variable on its own. And for your information, auto numeric node runs 15 to 16 machine learning algorithms on that variable automatically. It runs automatically by default 15 to 16 algorithms, what you're seeing on the left pane, without burdening the researcher to pick up any required algorithm on their choice. Yeah, time complexity is optimal, Professor Mahinder. It's not too time consuming, but it's optimal time. I'll show that. Click open and use custom fields. So choose, right click open and choose custom fields. And what is the target variable we are going to analyze? Yeah, see here. Sales in rupees transformed. Could you notice the transformed variable? Actually, our original variable is sales in rupees, right? Yeah, sales in rupees transform. If you want, you can transform the categorical. And here, add columns. Now tell me, participants, which of the input variables or fields do you think are going to affect the outcome variable? If not found, don't worry. You might find it as sales in rupees. If not found, don't worry, because I have transformed it, I am getting as transformed. If you find only sales in rupees, please add sales in rupees only. That's your target variable, sir. Okay. I think age might affect the sales outcome. Gender might affect the sales outcome. Location might affect sales outcome. While the nominal variable name and the unique variable sales executive ID, which are useless for our analysis, I'm ignoring them. Okay, once again, I'm repeating this step. So what we did is we just added one auto numeric algorithm for this. I'll just try to delete and add once again the benefit. This is taking a bit time on my machine. Okay, delete this. Let it get deleted. So that I'll just add again. There is a glitch, timeout. That's the error it is showing. It should get deleted actually. So we are adding a target node to determine the output variable for this. Once you add auto numeric, you will get the sales in rupees. Output variable is actually understood by your modeler tool. Okay, let's wait for the refresh here on my screen. Those who got it, that's good. Because of the timeout on the cloud, this takes some time to get back to the base state. It's not deleted yet. Now it's deleted, friends. Now I'm going back and adding it again, once again. Auto numeric. Yeah. I'll be answering certain questions, sir. Don't worry. Done. No targets defined. Now I'll just go and define my targets here quickly. Use custom fields, set my target as sales in rupees, and I'll just pick up my own columns, as I said, age, gender, and location. Click OK. Click save. Now, I just now got my sales in rupees. You have already got this thing. Right. Now, friends, we have built the workbench. Now it's time to run the analytics session. Right. We have built the workbench and now click run. Can you all see the run button on your toolbar at the top? Right. Just click run and wait for the algorithms to get completed. It takes few seconds based on the processing power, your RAM, your hardware accelerator, and the internet speed on your cloud access. This is the cloud version of the modeler. There is a desktop version available also for download, irrespective of working on the cloud also, without internet access. IBM SPSS modeler on a subscription is available for you to download, like you people could have downloaded IBM SPSS statistics officially from IBM's site. IBM SPSS modeler is also available with a free trial for a few days and then a subscription. So you can also click run. Once the algorithms run in the background, Yes, I'm done. All my algorithms have been run successfully, right? Now, how many of you also could successfully run that? Any error message, don't worry. See, a nugget is formed here. A small output node is formed here. Sales in rupees, right? It is formed here from the different algorithms. So those who got error, don't worry at all. Just open that and choose view model and choose view model. Now friends, see how SPSS modeler has actually built many different algorithms. See how many algorithms it has chosen. By default, during your run, you can customize the selection of the algorithms. By default, it is 5 algorithms, participants. You can increase the number of algorithms from 5 to 15 or 16, or you can reduce it from 5 to 3. The novel 5 algorithms have been listed out in the output, and you can see XGBoost training with 92.2% accuracy of predictions on training data, with followed by random forest, followed by generalized linear model, and XGBoost linear. So which do you think out of these 5 is actually learning the training data patterns to the greatest possible extent? Which do you think was learning great? You can see my screen. Yes, XGBoost was learning the best patterns from the selected predictors on their impact. So we could do a multiple linear regression with 3 possible predictors, even without knowing what best algorithm can work. Whereas in your IBM SPSS statistics, you have the privilege to run a simple linear, multiple linear regression, or anything. Yes, it differs, Madam Varsha. Either 100% accuracy is also possible based on the sampling split. Okay, based on your random sample, accuracy increases or decreases also. So this is how you build your model here. Now go back to your dashboard, sales performance analysis, right? Okay. Now you saw the model that the algorithms have been working with. View model. Click open if you want to change the further things. Right click and choose open. Under the settings. Okay, fine. This is already saved. Now friends, how many of you want to take away this statistics analysis into your report? The analysis is done, right? But how many of you want to catch away this in your research paper report? That's most important. Presenting the analysis in a report, right? Okay. Now, can you see the outputs tab finally? Can you see the outputs tab, participants? Outputs tab. Click outputs tab and drag table node and add it to your workbench. I request all the participants who could come here till successfully. Others need not worry. The session is under recording, entire practice. Click Outputs tab on the pane. Choose Table and drag it there. Also choose Analysis. You have one more option. Choose Analysis and place it exactly below. Now, connect the model to the table. A table of predictions will be built, and connect the workflow pipeline to analysis also. Build 2 linkages, everybody. So where will you build? On the models that you have built on your target variable. Link the model predictions and store them in a table. Similarly, analyze that predictions given by the model by dragging analysis node. Right? Okay. Now click table, right click and open. And you can save this. And click analysis and right click open and click save. Okay, analysis, save. When you right click on analysis, participants, can you see one option? Save branch as a model. Do you notice it? After you added the analysis node onto your workbench, would you all notice save branch as model? Everybody, please respond. Yeah, those who are there. That's it. Click save branch as a model. Right? You are saving your models, all the predictive models 5 models that appeared in our project, they are being saved to the IBM Cloud Object Storage Explorer in your IBM account. From there, you can download them and show in your research papers, in your consulting projects also. All the analysis is there from the workbench. Now, how many of you got the save model screen? Can you all see the save model screen? Yeah. Yes. Choose the analysis or a table. You can save it in the table and choose your model name, sales analysis. You can type sales analysis. So in the save model dialog box or the web page, save them under the table and sales analysis and click save. And click save. So you can see successfully saved the predictive models in your Cloud Object Storage Explorer. So they are ready for deployment. This is the advanced stage we use for deployment. If you researchers want to save your predictive models for putting them on your paper, you can save them, right? Now, double click on the table, or you can view the table, open, table settings. So all the models that you have built with your selected input predictors and a target have been saved to your object storage explorer. This is a way of building a very simple predictive model. Even when you don't know which type of algorithm to apply, you can go for auto numeric. If your outcome variable is categorical, friends, you can go for a auto classifier. But if you are a capable statistical researcher and have in-depth knowledge of all machine learning algorithms, you can choose a regression model for this problem. Or if your output variable is a categorical, you can choose a classifying algorithm such as a C 5.0 decision tree, C&R tree, classification and regression trees, random forest classifier, or if you are doing a forecasting model on a numerical problem, you can go for a time series forecasting also. So based on the problem statement, a mature researcher can pick up the appropriate algorithm, or a beginner can go with either auto classifier or auto numeric and pick up the best 5 of your choice. Even neural networks also possible, AI based artificial intelligence. This is for supervised models. For unsupervised problems, you can work with association rules a priori, and for segmentation, you can work with cluster modeling also. And all the dimensionality reduction models like PCA, factor analysis are also possible. Professor Mahinder, basically IBM SPSS modeler is used for text analytics, data mining with predictive modeling also, and a limited image analysis. Hope all of you understood this basic essence of this thing, right? So Jay, if you're there, to empower cross-industry standard processing data mining and to transform your intellectual knowledge into much more scalable research for industrial problem solving, there is a set of programs being offered by SmartBridge to actually scale this thing. Jay, could you show us if you're there?
Hello, sir.
Hemant, yeah.
Yes, sir. Sir, Jay sir is not there as he has some network issues. I'll be sharing the screen. Yukesh sir, please give me the share option.
Yeah, Hemant, just a second.
Sure, sir.
You got access now.
Mr. Hemant is going to show you all with the possible extended plethora of research opportunities on diverse industrial problem statements to transform academic researchers into industry scientists of the future on this IBM SPSS modeler platform. Take a quick look at possible opportunities to explore with IBM and SmartBridge. There are a set of predefined programs identified to escalate the research skills, transforming the researcher into a industry scientist for tomorrow's real world problem solving. How many of you believe that your research publications published in your lifetime need to be read, need to be used by society, should be useful for society? In fact, every one of you actually intends the same. Then, my dear friends, look at the wonderful opportunity SmartBridge is coming up with. Several industry-oriented, research-oriented certification programs in data sciences and analytics. Scroll down. Hemant, scroll it down, your screen. Data-driven marketing practices. A computer science engineer, electronics engineer, mechanical professor, engineering professor, even a civil engineer can also build up predictive models for marketing agencies with a little bit of marketing knowledge with IBM SPSS modeler. Understanding the workbench flow with streaming analytics gives you additional edge of research, transforming you to be a future scientist on various consulting problems in marketing domains. Banking sector is yet another industry that is flourishing globally across. We all know that. Several challenges of credit risk modeling is still a day of challenge for many banks. The course on predictive analytics for retail banking with IBM SPSS modeler and visual practices with Tableau is a new discovery of research for many esteemed intellectual faculty pools like you. Energy management, utility sector also requires your research expertise to develop smart solutions for day-to-day complex problems like managing renewable energy with predictive analytics. HR practices with workforce analytics, HR management requires understanding in-depth practices of employee satisfaction, employee turnover management for better prospects of organizations. Similarly, healthcare industry also requires complex and advanced research practices with these kinds of trends and techniques. So, my dear friends, in the time limit possibly given and with your undoubted patience that you have been giving to me from the last 1.5 to 2 hours nearly possible, I really appreciate your concern, taking part in this GuruCool program, putting up your best efforts, and I really wish you all the best to go one step ahead from a core academic researcher to tomorrow's industry data scientist. With this, I take the pledge honor and thank SB and SmartBridge and IBM, the host partner, technology partner, for inviting me for this technical session. God bless you all. Stay safe. Thank you.
Thank you, Mohan. Thanks a lot for your wonderful session. It is side. So I think with this we have like done with the 5 days of session, and we have really ended the 5th day with a high note of your very good lecture. So thank you all participants, faculties. It's like we have 8 past 20 minutes, but still we could see maximum faculties are still on. So that itself says how session went very well. So thank you so much, all the SmartBridge team, being staying for all 4+ hours. Last 6th day of training, so you will be getting exposure to very interesting topics like cloud native, Kubernetes, OpenShift as such. So request all faculties to don't miss the session tomorrow. So you will be getting a couple of speakers from couple of companies. One is from IBM. The design thinking will be done by IBM, and OpenShift session will be done by Red Hat. So very various segment speakers will be coming tomorrow for you to teach on OpenShift and design thinking. Okay, so let's call off for today, and I hope all faculties are getting in touch with mentors. So mentors, please answer all the questions if any questions have missed. So guys, please respond in the Telegram group as well. I could see a few questions are unanswered over there, and even Slack as well. So tomorrow is the last date of the training, and faculties are supposed to select the project which you would like to work on. So I request you to give a look tonight, if possible, maybe tomorrow also, and just try to confine with the one minimum one. You can always go and choose 2 or 3 as well, as per your wish, but request you to choose the best which suits you, right? So that from tomorrow only we can start off mentoring you guys on building the project, right? Thank you all. So we'll close the session for today. Thank you all.
Thank you, Hitesh. Thank you, Team IBM. Thank you, Team SmartBridge.
Thank you, Mohan. Thanks a lot. I'm closing the session now. Thank you all. Good night.